There's a stretch of water that even the most experienced explorers fear. No matter what season you choose to cross it in, you risk meeting face-to-face with waves that can reach as tall as the Hollywood sign. I'm talking about the Drake Passage, the waterway connecting the Pacific Ocean to the Atlantic Ocean, stretching from Cape Horn at South America's southernmost tip to Antarctica's South Shetland Islands. It's about as wide as the distance from London to Berlin and takes up to 48 hours to cross. Some sailors compare getting on the other side to going to the moon. That's how challenging it is. Even the man who discovered it, Sir Francis Drake, never sailed these waters because they seemed too dangerous to him and opted for a calmer, although longer, Strait of Magellan. The passage took the lives of around 20,000 sailors and over 800 ships. Tourists who want to see Antarctica cross the Drake Passage on a regular basis, although it's still often called the world's most terrifying ocean crossing. The Antarctic Peninsula, where travelers go, isn't really part of Antarctica itself. It sticks out and points towards South America like two fingers almost touching it. The water gets squeezed between these two land masses, making strong ocean currents. The passage is part of the Antarctic Circumpolar Current, the largest ocean current on Earth. The water rushes through the passage at a speed between 95 and 150 million cubic meters per second, which makes it rougher. And then there are winds that usually blow from west to east and are very strong between 40 and 60 degrees latitude. That's why those areas are called the Roaring Forties, Furious 50s, and Screaming 60s. Land slows down winds, which is why storms hitting Ireland and the UK get weaker as they move east. But Drake's latitude is the only place where winds can blow all around the Earth without being stopped by land. So they keep getting faster. These strong winds turn into huge waves that can hit ships really hard, normally around 13 to 16 feet tall. They're much higher than waves in the Atlantic. Drake Passage also has underwater mountains that you can't see. The huge current squeezes through this narrow passage and causes waves to crash against these mountains underwater. These internal waves create whirls that bring cold water up from the deep ocean. So it's not just rough on the surface, the water is wild all the way down. The first sailor managed to sail around Cape Horn and through the Drake Passage in 1616. It was a Dutch navigator, Willem Schouten, in 1616. But the most famous attempt to cross it was undertaken by Sir Ernest Henry Shackleton on his ship named Endurance. He and 27 of his men set off from South Georgia, aiming to reach Vassal Bay in Antarctica. But things didn't go as planned. On January 19, 1915, their ship got stuck in the ice. And by October, it began to sink. They camped on floating ice for 2 months before sailing lifeboats to a remote, icy place called Elephant Island. Shackleton and 5 men made a risky journey to South Georgia to get help. It took them 15 days to cross Drake Passage with hurricane winds. Finally, they arrived safely and organized a rescue for the rest of their crew. Scientists found the shipwreck of Endurance only in 2022, 10,000 feet below the water. In December of 2019, 6 fearless athletes decided to cross the Drake Passage by rowing a boat for the first time in history. It took them 12 days of non-stop rowing with a 90-minute rotation of rowers. They managed to do it, and it was probably the hardest possible way to cross the passage. The athletes mentioned it was cold, wet, and dirty, and the waves hit them like walls. The weather in the Drake Passage changes a lot, but ship captains can always see it coming and change their path. They will move the departure time to have a safety margin and not to get stuck in the middle of the passage in the worst possible conditions. Sometimes, the journey will be smooth and calm, and they call it Drake Lake. Other times, people on the ship will feel rough waves, which is called Drake Shake. Some experienced captains who often cross the passage say that the Drake Lake effect happens once in every 10 crossings. And they see the Drake Shake once or twice in every 10 journeys. A schooner or a kayak will probably not survive the journey among giant waves, but modest vessels and cruise ships have sturdy hulls and advanced stabilizing mechanisms. So, the journey isn't that dangerous anymore. But still, it's quite an adventure, especially if you're seasick. If you don't feel like risking it but want to travel from the Pacific Ocean to the Atlantic Ocean by water the fast way, the Panama Canal is waiting for you. People first started thinking about making a water path across Panama in the 16th century. Back then, a Spanish explorer found out that only a thin piece of land separated the two oceans. But it seemed impossible to build it because of the mountains and thick jungle, so the idea had to wait a couple of centuries. Finally, in 1880, France, led by the man who built the Suez Canal in Egypt, tried to make the canal. But the people who started the construction soon found out it was much harder than it looked on a map. The land in Panama was one of the toughest and most dangerous places to dig a big waterway. Workers had to literally move huge mountains in a jungle full of snakes, where it was really hot and rainy. During the wet season, heavy rain turned rivers into wild rapids and soaked the workers. Sometimes, they didn't see the sun for 2 weeks, and their clothes stayed wet all the time. Big rocks were falling, and tiny mosquitoes that carried malaria made people very sick. And then, an earthquake happened on top of everything. They were losing thousands of people. That's why France decided to abandon the project after 7 years. Then, the United States bought the French assets in the canal zone and finished it by 1914. It cost the US around $375 million. The 50-mile-long passage of water saves ships traveling between New York and San Francisco 7,872 miles. Around 14,000 ships use it every year and pay around $1.8 million in tolls. So it looks like it all paid off. Another challenging waterway in this part of the world is the Amazon River. It's around 4,300 miles long and flows through 3 countries with over 30 million people living in its basin. But there isn't a single bridge across it. The river has many marshes and soft soils, so engineers would need to build very long bridges and very deep foundations, which costs a lot of money. Building bridges over deep water is tough, but in other places in the world, engineers can use things like floating platforms to help. The river's path and water levels change a lot during the year. During the dry season from June to November, the river is usually 2 to 6 miles wide. But in the wet season from December to April, the river can become as wide as 30 miles. And the water level can rise by 50 feet. That's why they can't build floating bridges or pontoons. The riverbanks are made of soft dirt that moves and erodes with the seasons, and it makes things even harder. It would have to be an absolutely unique project to overcome all these challenges. Luckily, there's no pressing need for a bridge across the Amazon right now. The river mostly goes through areas that are sparsely populated, so there aren't so many major roads to be connected by bridges.
Around 2,500 years ago, an earthquake completely changed the course of one of the largest and most famous rivers on the planet, the Ganges. Now, it's normal for rivers not to sit in one place, so if you live next to one, it could also just disappear without a trace or flood the whole city one day. In the case of the Ganges River, a supermassive earthquake became the reason for this dramatic change. Scientists say it might happen again, and it would be a huge problem for millions of people who depend on this river. The Ganges River starts as small streams in the Himalayas and travels a long way, over 1,500 miles. Along its journey, it meets other big rivers before all the water flows into the Bay of Bengal. The Ganges has the largest delta in the world among all rivers. Just like many other rivers in the region, it slowly changes its path over time. These changes, if they happen when a river wears away its banks, usually takes a long time, sometimes decades. Scientists have discovered that the Ganges-Brahmaputra river system has shifted several times over the last 6,000 years. When they looked at satellite images of the Ganges Delta, they noticed something interesting. There was a crescent-shaped dip in the ground about 28 miles away from where the river is flowing now. This depression was over 1 mile wide and stretched for many miles. They thought it might have been an old main channel of the Ganges River a long time ago. In 2018, the team decided to visit the area to check it out for themselves and take samples to learn more about it. While driving back home, they noticed a pit where someone was digging dirt to create a pond. The next day, they planned to fill it with water, but the researchers spotted something strange in the dirt. There were vertical bands of light-colored sand mixed into the darker mud. These special layers are clues from the past. They show that an ancient earthquake made sand and water shoot up from below the ground and created sand volcanoes that were trapped in time. The scientists studied the sand and mud and figured out that these earthquakes happened around 2,500 years ago and were strong, with magnitudes of 7 to 8. The epicenter was over 110 miles away from the main stem of the river, but it was powerful enough to displace it. It could have affected around 140 million people. The Ganges-Brahmaputra system is close to spots where Earth's tectonic plates meet, so earthquakes happen here often. There's no danger right now, but scientists think that another massive earthquake could happen in the next few hundred or thousand years. It could threaten up to 170 million people. That's about half the population of the U.S. No one can predict exactly when an earthquake will happen or how strong it will be. Learning how earthquakes in the past moved rivers helps scientists figure out patterns and make guesses about similar events in the future. This knowledge could help us prepare better and create safety plans before another big earthquake strikes. Now, the Ganges isn't the only river at risk. The Yellow River, the Irrawaddy River, and rivers in the United States, like the Klamath and San Joaquin, all face similar dangers. The mighty Mississippi River has also switched its path many times over the last 7,000 years. Right now, there's a huge system of dams and barriers called a control structure in central Louisiana. This structure's job is to stop the Mississippi from spilling over its banks and joining a nearby river. But scientists think that, in theory, these barriers wouldn't handle mega floods. So the Mississippi could break free and change its course again. This would cause massive problems, especially in southern Louisiana. One of the recent examples when a river changing its course caused disaster was the Kosi River in India. In August 2008, over just a few days, the river's path shifted by almost 60 miles, which is a huge change. Floods happen in some parts of the state rather often, but they hadn't seen such strong ones in over 50 years. They affected around 1,000 villages and 3 million people, and about 1 million people had to be evacuated to safety. Since many of these people hadn't faced floods in so long, they weren't ready to handle it quickly. It caused even more damage to their homes and lives. Scientists have been trying for decades to figure out what exactly makes rivers suddenly change their course. A new study explains that two things work together to make a river to do it. This process is called avulsion. First, there's the setup, which is like building up tension before something big happens. Over time, sediment, sand, dirt, and other stuff carried by the river gets deposited in certain places. It either raises the river above the land around it or makes a nearby slope steeper than the river's current path. Then there's the trigger, which is like the final straw that makes everything happen. This trigger could be a big flood, an earthquake, or even something like a pile of logs blocking the water. Now, researchers looked at satellite images of about 170 cases of avulsion from the past 50 years. They noticed these events happen most often near river mouths and near mountains. Rivers were about 3 times more likely to change course in these places than in the areas between them. They also studied 58 river channels in detail, using super clear maps to measure super elevation. That's how high the river is compared to the land around it. They also measured slope advantage. That's how steep a new path might be compared to the river's current one. They found that near mountains, rivers often pile up so much sediment that they become super elevated and spill over. But near river mouths, like in deltas, rivers need a steep slope advantage to break through the mud and form a new path. These two factors work together like a seesaw. If one is stronger, the other doesn't need to be as strong for an avulsion to happen. To figure out where a river might go if it changes course, the researchers created a smart computer algorithm. This tool uses maps to measure the terrain's steepness and the river's flow to predict where the river might move. They tested it on 10 past avulsions, and it correctly guessed the path every single time. Scientists hope they could use these findings to protect people living near rivers from sudden floods. Rivers changing course played a big role in creating one of the first organized administration systems in the world. Scientists found clues for this in the territory of ancient Mesopotamia. This name means the land between two rivers, and it was between the rivers Tigris and the Euphrates. People living there relied on these rivers for water, food, and transportation. Scientists wanted to figure out how these sudden changes in these rivers affected ancient people. To do this, they used two kinds of maps. The archaeological maps show how ancient cities grew over time, including what types of buildings people built. Certain buildings, like big palaces or city walls, could show when each city first had an organized administration. The second kind of map showed where the Tigris and Euphrates rivers flowed long ago. They often shifted, sometimes slowly, and sometimes very quickly and dramatically. Around the year 5000 BCE, Mesopotamia started to become drier and farming became harder. Farmers had to grow their crops near rivers, where they could use the natural floods to water their fields or dig little channels to bring river water to their plants. Because farming was so important, towns and cities grew near the rivers too, so people could stay close to their food. But when a river suddenly changed its course, people didn't give up. They worked together to dig long canals to bring water from the new river path back to their fields. The canals helped them get water again, and the administration buildings showed they were organizing as a community to solve big problems together. Imagine you're driving across a bridge to visit a friend. The next day, you get in your car to go back, but there is no longer a river under the bridge you drove across yesterday. Believe it or not, this is exactly what happened to people in the south of Honduras when Category 5 Hurricane Mitch hit in October 1998. Choluteca Bridge, which the local authorities reconstructed earlier that year, was left in the dry, as the river now flowed around it, not under it. The structure soon became famous online as the Bridge to Nowhere. This waterway shifted its course overnight, but it normally happens over longer spans of time. A river will stop flowing straight when there is even the tiniest change in the landscape around it. Even something as tiny as a mouse can weaken a riverbank. Imagine a family of mice decides to start a home somewhere by the river and digs a cozy hole. Over time, water gets inside this hole and starts washing away any loose soil. Give it a couple of centuries, and the river will now have a bend in this place. And if you're worried about the mice family, don't be, because they moved out a long time before the water flooded their home. Things happen even faster for small streams because, well, their beds are also smaller. The current breaks down stones, the ground takes them in, and voila, a riverbed or bottom is formed. The current is the strongest in the middle of the waterway, and its power directly shapes the riverbed. The water flowing through rivers is full of soil and other particles. All this stuff goes from the spring into the mouth of a river and into Earth's oceans. In some cases, these particles build up at some point, and that's how new beaches, probably including your favorite, are born from fine-grained sand. On the other side of the river, the flow of water is much faster, so this fast-moving current literally slams against the next bank. Then, the process of erosion starts all over again. River erosion is what happens when the flowing water takes away soil. And I have to tell you, things go super fast there. That water is so energetic, it can even carve into rocks, creating a canyon. If the riverbanks consist of loose material, such as humus, that's the soil you plant a flower in, then it is easier for the flowing water to erode it. Rivers in the plains are often wide and slow because there's little resistance from the ground around them. So you don't have to worry about waves tipping over your boat on a flatland river. In the mountains, streams quickly wash away all the surface soil and gravel, revealing the bedrock beneath them. It's tightly bound, so mountain streams are literally set in stone, as they cannot wash away this bedrock. So we have erosion to blame for waterways changing their course, and also mountains and hills. When a stream reaches a mountain or simply a rock, it has two choices: to flow around it or carve its way through it. In flatlands, rivers don't have any natural competition, so they choose a more winding path. All this twisting and turning increases the river's total length from the source to the mouth. One such example is the mighty Mississippi River in the U.S. It has a lot of curves and bends, which are called meanders. In the last century and a half alone, the Mississippi changed its course several times. The last major case was in 1876 when it left the historic city of Vicksburg in the dry. 2 years later, a team of American engineers came to the area to construct the Yazoo Diversion Canal, which took 25 years to complete. Thanks to it, ships could once again sail to Vicksburg, reviving the town's economy. What happened in this southern U.S. town in the 19th century is an ordinary natural consequence of river erosion. The bends in a waterway grow sharper over time, making the water flow faster. This speeds up erosion, and individual bends slowly start approaching each other to the point they merge. When this happens, the river straightens up overnight, leaving a lake in the form of a horseshoe in the place where the bend was. This newly formed body of water is called an oxbow lake. These still water lakes either dry up, since they're no longer fed by a spring, or they turn into swamps. In some cases, humans use them as water meadows used for agriculture. Lake Chilkat in Arkansas is the largest oxbow lake in North America, formed by the Mississippi several centuries ago. The source of the Mississippi is a lake in Minnesota, but a river can also start when two other watercourses become one, or when the water simply bubbles up from under the ground. Even melting snow can feed a river, like the Amazon gets its water from the Andes. Determining the source of a waterway can be tricky, so the debate about whether Amazon or the Nile is longer is still ongoing. What scientists know for certain is that the Amazon carries more water than any other river. 1/5 of all the fresh water that enters Earth's oceans comes from this South American river. When you look at the Amazon River on a map, you'll notice how it flows from Peru to Brazil, that is, from the west to the east. This direction might seem odd when you compare it to the Mississippi, which flows to the south on the map. It's so confusing because you probably know rivers flow down, affected by gravity. But down doesn't automatically mean south. Running water will try to find the easiest route down, so there are no rules in terms of cardinal directions. The Nile River is the best example of this, as it actually flows north into the Mediterranean Sea. Northern Egypt, where all those pyramids are located, is on lower ground than Sudan, where the Nile is formed when the Blue Nile and the White Nile merge. Ab in northern Asia and the Mackenzie River in Canada both flow northwest, while the Yellow River in East Asia flows in the same direction as Amazon, to the east into the Pacific Ocean. These major rivers are some of the best examples that a stream doesn't have to flow from the north to the south. Gravity is the only important factor that determines which way a stream will flow, as running water is all the time pulled downwards. The flow of water is faster on steeper slopes. When there's a sudden drop in the flow, waterfalls form. Angel Falls in Venezuela is the highest waterfall on the planet, with water dropping from a height of 2,600 feet. Watch your step. In a waterfall, the falling water can easily reach the speed of a Thompson's gazelle, but as a river approaches the end of its journey, it slows down significantly. The stream doesn't have enough energy to cut into the nearby land. All the sediment it has picked up along the way, such as sandstone, slows it down. At the place where a river meets the ocean or a lake, it gets rid of this sediment along its banks, creating a delta, an area rich in fertile soil. The Ganges in India has the biggest delta in the world, several hundred miles wide and visible from space. The Amazon, on the other side, doesn't have a true delta because the strong currents of the Atlantic Ocean wash away everything the torrent brings. The deepest section of the riverbed that runs along its middle is called a channel. This is where the current is the strongest, so ships travel on top of these channels. When engineers want to expand a waterway, they simply dig a deeper channel and voila, larger ships can now pass. This is just one way humans alter watercourses. We often strengthen the banks of a river to prevent erosion or build dams that stop or divert the flow of water. The oldest operational dam on the planet dates back to the time of Egyptian pharaohs. It was, of course, the first damn thing. So, contrary to popular belief, labeling the Nile as the longest river in the world might be a misconception. The measurement of a river's length entails more than simply calculating the distance between its starting point and end point. Rivers are intricate systems comprised of various tributaries, which significantly impact their overall length. In fact, when accounting for these tributaries, the initial figure can increase up to threefold, exemplified by the Mississippi River. From its origin in Itasca to its conclusion in New Orleans, the measurement suggests one length. However, the inclusion of the Missouri River alters this perception entirely. This discrepancy has fueled ongoing debates regarding the Nile's length compared to that of the Amazon River. Despite Google's recognition of the Nile as the longest river worldwide, it may not fully align with the factual reality. That's a nice way to put it. To comprehend this concept, envision rivers as the veins within a human body. It would be inaccurate to assume that a 6-foot-tall individual only has 6 feet of veins, right? Veins intricately weave throughout the entire body, much like a vast network. Rivers operate under the same principle, and the length of the main river is not the sole consideration. The extensive network of tributaries holds equal importance. Meanwhile, atmospheric rivers are fascinating meteorological occurrences, characterized by air currents that transport incredible amounts of water vapor all the way from the Amazon rainforest in northern South America to as far as northern Argentina. These airborne highways serve as essential conduits for the life-giving moisture carried by these airborne rivers, and their influence extends across Brazil's central west, southeast, and south regions, shaping the waterfall patterns in these areas. When these ethereal rivers converge with specific weather conditions, such as a cold front, the latent humidity they bear can transform into much-needed rainfall. This precipitation plays a vital role not only in sustaining the diverse ecosystems of the region, but also supporting Brazil's thriving economy in multiple ways. The significance of this phenomenon is evident as it enables the irrigation of crops, ensuring agricultural productivity and food security. Additionally, it replenishes local rivers, keeping the water flow steady and supporting aquatic life. Moreover, the water collected by these rivers is channeled into dam reservoirs, providing a reliable source of energy for the nation. The amount of water carried by the airborne rivers may match or even surpass the enormity of the Amazon's flow. Thus, when we unite the conventional Amazon River with its aerial counterpart, it becomes significantly larger than the Nile. Atmospheric rivers are also observed in the Congo Basin, where the climate is predominantly shaped by the moisture emanating from the Atlantic Ocean and the forests of the Congo Basin. This incredible phenomenon leads to evaporation levels as high as 3 to 6 feet of water per year. These rivers vary in size and strength, but on average, they transport a water vapor volume comparable to the flow at the mouth of the Mississippi River. In rare cases, exceptionally powerful atmospheric rivers can carry up to 15 times that amount. When these rivers reach land, they release the accumulated water vapor, resulting in rainfall or snowfall. Although atmospheric rivers come in various forms, those with high water vapor content and intense winds can cause extreme precipitation and flooding, especially when they linger over flood-prone watersheds. An example of a well-known atmospheric river is the Pineapple Express, a robust system capable of transporting moisture from the tropical regions near Hawaii to the U.S. West Coast. Such events can disrupt travel, trigger mudslides, and lead to significant destruction of life and property. However, not all atmospheric rivers pose risks. Many are weaker systems that provide valuable rain or snow, essential for maintaining water supplies. Plus, they play a critical role in the global water cycle and have a close association with water supply and flood hazards, particularly in the western United States. In addition for the potential for flooding, atmospheric rivers also contribute to desirable increases in snowpack. A series of atmospheric rivers was responsible for severe winter storms that battered the U.S. West Coast from western Washington to southern California between 2010 and just recently in early 2024, resulting in rainfall ranging from 11 to 25 inches in certain regions. So, if water vapor can be considered a river, it begs the question, what else can be classified as a river? Surprisingly, even without any water, something can still be deemed a river. This fascinating phenomenon is known as a wadi, traditionally referring to a river valley. Wadis can be found in gently sloping, almost flat areas of deserts. Unlike traditional rivers, wadis lack permanent channels due to the sporadic presence of water flow. As a result, they exhibit braided stream patterns caused by limited water supply and an abundance of sediments. The water that does manage to reach the stream bed percolates down, causing a sudden decrease in energy and significant deposition. Additionally, wadis can develop sediment dams, altering stream patterns during subsequent flash floods. Interestingly, wind also plays a role in sediment deposition within wadis. When wadi sediments are submerged or moist, wind-driven sediments settle on top of them, resulting in a mixture of both water and wind sediments. Rivers can be peculiar not just because they consist of sand or air, but also because of their fascinating coverings. In certain conditions, Scotland's River Dee reveals an intriguing sight: peculiar frozen formations that resemble lily pads. These formations, called ice pancakes or pancake ice, occur naturally when gentle waves cause smooth pieces of ice to collide, resulting in smooth rounded edges. As these ice disks interact with the waves, they gain raised edges, giving them an appearance reminiscent of lily pads. Usually, pancake ice has a somewhat slush-like consistency. Some media reports have suggested that the ice on the River Dee formed from frozen foam. But scientists explain that while it is plausible, the pancake ice still develops through the collision process. Over time, these ice pancakes often merge together, forming large sheets of ice. If the ice becomes thick enough and the water remains turbulent, it can bend, fracture, and stack upon itself, creating remarkable structures called ice ridges. Now, imagine a river not made of water but of methane. It may sound like an outlandish idea, but on Saturn's moon Titan, this is actually a reality. Vid Flamina, a fascinating river on Titan, consists of liquid methane and ethane and has drawn comparisons to the mighty Nile. Stretching over 249 miles, it gracefully flows into l'Egea Mare, which is Titan's second largest hydrocarbon sea. While most of Titan's surface is composed of water ice, Vid Flamina stands out as a breathtaking river that carves canyons into the icy terrain, mimicking solid bedrock. NASA scientists believe that this extraordinary river hosts rapids, whirlpools, and even waterfalls, mirroring the features found in Earth's rivers. When NASA's Cassini probe reached Saturn in 2004, its main goal was to explore this giant planet and its moons. Scientists were particularly interested in finding evidence of liquid methane on Titan due to its unique surface temperature and methane-rich atmosphere. However, initial observations from Cassini, concentrated on Titan's equatorial region, disappointed the researchers as they found no signs of seas or rivers. But this disappointment turned into excitement when Cassini's orbit shifted, enabling the team to focus on other areas of Titan's surface using radar techniques. Surprisingly, radar signals bounced off various angled and rough features such as sand dunes, cliffs, and rocks. But when the radar reached Titan's polar regions, the signal ceased, revealing mysterious dark spots resembling lakes, rivers, and tributaries akin to those found on Earth. The groundbreaking discovery came in December 2012 when Yanni Radebau, a scientist working with Cassini's team, announced an image captured in September of the same year. The image unveiled a river resembling the Nile, extending over 200 miles in a relatively straight course, indicating a correlation with fault lines similar to other significant rivers nearby. This remarkable flowing body navigates through rugged and inclined terrain, suggesting the occurrence of tectonic processes comparable to those on Earth. Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit. But the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink seawater. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about ocean's past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps. Each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet. Most rivers in the world flow into the sea, but the Okavango in Africa takes its massive waters right into the Kalahari Desert, and it looks like this river manages to do the impossible and defies gravity. The Okavango starts in the highlands of Angola, runs for 1,000 miles like any other normal river, and then drops into the largest inland delta on Earth, known as the Okavango Swamp. The delta has land slopes dropping at nearly 150 feet, which is about half as tall as the Statue of Liberty. The area where the Okavango Delta is now used to be part of a lake that dried up around 2,000 years ago. It takes the Okavango water several months to complete its journey, and the landscape there is never the same. The first European to have found the delta was the Scottish explorer David Livingstone. Yeah, the Dr. Livingstone, I presume, guy? That's him. When he first saw it, he was shocked as he noticed that the water seemed to be flowing backward and even uphill. He saw two strong watercourses connecting the Okavango to the wetland systems to the east. Decades later, other explorers saw them completely dry. Several years later, the watercourses were full again, and they kept emptying and filling up, sometimes changing direction. Scientists managed to explain this mystery when they found a hidden network of faults, part of the Great Rift Valley, under the sand. When major earthquakes happen, like the one in Indonesia in 2004, the Earth sets off a chain reaction. Tiny cracks underground shift just enough to send a trickle of water down the river, and a flood begins, raising the water levels. Plus, in May and June, when winter begins in the southern hemisphere, floods bring more fresh water and life to the swamp. Islands get submerged completely during the peak floods and then resurface again at the end of the wet season. Wildlife just loves all the water in the delta, and you can often see migratory elephants bathing among pink lily pads and silverfish, bream, barbels, and other fish. There are lions, cheetahs, buffalo, wildebeests, hippopotamuses, hippopotami, zebras, wild dogs, crocodiles, and other species of animals. Storks, ibis, herons, cranes, and geese like to fly by, along with 450 species of birds. Although the Okavango has plenty of water that is priceless in the desert, people hardly settle along its banks. One big problem here is the tsetse fly. But if you're feeling adventurous, you can come here for a water safari. Scientists from Imperial College in London stumbled upon a totally unexpected river under the Antarctic ice sheet. It slurps up water from an area as big as Germany and France combined. Scientists used to think the lakes under the Antarctic ice were just chilling by themselves. But now it turns out they're part of an interconnected river network. Water under the ice can form in two ways, either from melted snow seeping down or from the Earth's natural heat and the ice grinding over the ground. The Antarctic gets a lot of surface melting during the summer, but Antarctica is usually too chilly for that. This newly found river is proof that there's plenty of water down there just from the ice melting from below. This river could make Antarctica lose its icy cover way faster. If things heat up enough to melt the surface, that water could rush down and mess with the base of the ice sheet, turning Antarctica into a melting mess like Greenland. If the ice starts moving faster than the water can handle, it's going to create more friction, making even more water and speeding up the melting process. The researchers are on a mission to dig deeper into how this river system works and see if it's causing trouble in other parts of the icy continent. Understanding what's going on down there could give us a heads up on how a changing Antarctica might shake up the whole planet. The Roe River in Montana flows for just a bit over 200 feet between Giant Springs and the Missouri River. It was mentioned in the Guinness Book of World Records as the shortest river in the world, but they had to remove this category altogether because there was some heated debate over this title. Residents of Oregon claim that their Dee River was the absolute champion, as it all depends on when you measure them. There could even be shorter rivers in Norway or Indonesia, depending on what you see as a river. The official definition says it's something that has constant flowing water in the form of a current and is fed by upland sources or another river, lake, or watershed. Creeks and brooks flow together to form streams. Streams become rivers, and rivers take the water from higher to lower lands, ending in the ocean. There are 12 stream orders, and the first two levels don't have other streams feeding them. So, Roe and its other short buddies technically deserve the title of rivers. I'm glad we cleared that up. Rio Negro in South America is the largest blackwater river in the world and the largest left tributary of the Amazon jungle. Its waters look more like strong tea and seem pitch black only from the distance. They get that dark color from humic acid. When plants containing phenol break down only halfway, they leave behind this tea-like hue. Some people believe that blackwater rivers can't be productive, But Rio Negro helps big fishing industries and has spots where turtles come to lay their eggs. Back in the 17th century, explorers didn't find tons of indigenous folks along the river. But it probably didn't have to do with its productivity, more with diseases and conflicts. There are around 700 different fish species documented in Rio Negro's basin, including at least 100 you won't find anywhere else. A bunch of those fish end up in aquariums, like the super popular cardinal tetra. There is a canal connecting Rio Negro and the Orinoco, which is another major river in South America. Many aquatic species try to move between the rivers, but only the toughest can handle the mix of blackwater and clearwater sections in that canal. There's a unique creek in Wyoming that drains both into the Pacific and the Atlantic Oceans. It begins high up in the Teton Range and later splits into two branches. The Pacific Creek joins the larger Snake River, which merges with the Columbia River and finally reaches the Pacific Ocean. The Atlantic Creek heads east and flows into the Yellowstone, Missouri, and Mississippi rivers and eventually empties into the Gulf of Mexico. If you connect the two creeks' watersheds on a map, you'll get a single blue line between Oregon and Louisiana. Explorers who were looking for the Northwest Passage between the two oceans never knew they could have used the creek. They would just need really tiny boats. Some scientists believe that cutthroat trout knew about this route long before people. They managed to migrate from the Snake River to the Yellowstone River, most likely using the Two-Ocean Creek. Now, every summer, the Caño Cristales in Colombia turns into a liquid rainbow, or the River of Five Colors. At this time, and until the end of fall, the conditions are just perfect for the riverbed to turn bright red, yellow, green, blue, and black. You gotta thank certain aquatic plants growing in the river, a special type of seaweed for all this beauty. During the wet season, the river moves fast and the sun cannot get to these plants. When the dry season hits, there isn't enough water to feed them. So the time in between the seasons has the perfect conditions for this colorful show. No other place in the world has anything similar. So at some point, the number of tourists who wanted to see it became so huge that scientists got concerned it could be bad for this hotspot of biodiversity. The area is home to rare species of animals, birds, and plants. Now, there are ecotourism trails and strict opening hours for visitors.
Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more, but getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city, except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria, but hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system.
The Earth has three main layers: two parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon, and made of nickel and solid iron. It's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which, in turn, protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
Oh wow, there's a hole in the bottom of the ocean. It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish, okay, this one kinda looks normal until you raise it to the surface, the goblin shark, Sloane's viperfish, zombie worms. Ugh, yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn.
Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years, and it does show. See for yourself. Due to such a long isolation, the conditions inside the Moval Cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave, and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide, so not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. 2 miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the Giant Crystal Cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super-tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7 feet wide structures mystery circles. The enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths. There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andres Russo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andres Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. The water in it was indeed steaming hot. Its temperature was 186 degrees Fahrenheit, not boiling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind on our planet.
On a sunny day, a man was diving in shallow waters near South Africa. At one point, he saw something that didn't catch his eye at first. A pile of shells that looked as if it had been put together. Maybe by some other diver, he must have told himself. But out of all these shells came the most unusual of creatures, an octopus. The gorgeous underwater animal looked straight at the man before swimming away. Impressed by his new acquaintance, the diver started visiting the octopus every day. He watched it use shells and seaweed to protect itself and learned how it hunted and cared for its eggs. All these encounters became the basis for a now famous documentary. In the movie, the diver wanted to study the relationship between a wild octopus and its observer. Initially, the octopus was a bit too shy to let the man get close. But over time, it began to trust him and even explored his body. At one point, the octopus even rested on the diver's chest. The man soon began to look at the underwater creature as his octopus friend. Sure, the documentary did make it look like a true friendship, but that was most likely because of all the close-ups and eerie music. But you can't really know what the octopus is thinking. Maybe what looks like tenderness is just curiosity or confusion. Maybe an apparent hug is really just a defense mechanism. Some people may love octopuses, but can they really be friends with a human? Until they learn to talk, I guess we'll never know. That doesn't make an octopus less of an interesting creature, though. Apart from those quirky sets of tentacles, obviously, octopuses have another characteristic that sets them apart from other sea creatures. A recent study that involved studying the footage of octopuses living underwater shows that they sometimes develop this unusual behavior. They seem to throw things at each other on purpose. It can be anything from dirt from the bottom of the sea to shells or rocks. Octopuses are known to be solitary creatures, so when something or someone, like an underwater camera person, gets too close to them, they might lash out. Just as we have yet to discover the limits of our galaxies and constellations, we know very little about the bottom of the sea. It's one of the reasons why we find it so hard to explain the behavior of some underwater creatures. The truth is, we don't have good enough technology able to deal with harsh conditions and a limited amount of light underwater. You might have asked yourself at one point, what's the deepest part of the ocean? It's called the Mariana Trench. We don't really know exactly how deep this giant hole is, since it's too difficult to measure, but it's somewhere around 6.8 miles deep and 5 times longer than the Grand Canyon. This massive underwater trench was first studied back in 1875 with the help of a weighted rope. Back in 2012, a Canadian film director reached the bottom of the trench in a submersible vessel called the Deep Sea Challenger. Some of the most bizarre creatures on the planet were discovered here, including the Dumbo octopus, the sea cucumber, and the goblin shark. The Mariana Trench got its name from the nearby Mariana Islands, which were named Las Marianas in honor of Spanish Queen Mariana of Austria. The Mariana Trench might be the deepest part of the ocean that we know of. But one other mysterious phenomenon that's interesting for researchers is called phantom bottoms. In the late 1940s, when the sonar became standard equipment, ships and submarines noticed unexpected signals coming from the ocean. Those signals came from areas where no seafloor was supposed to exist. What's even more mysterious is that this fake seafloor appeared to move. One researcher at Scripps University found out that these phantom bottoms showing on maps were indeed alive. They were made out of a layer of jellyfish, shrimps, and other deep-sea creatures. The reason why they move is that they rise to the surface at night to feed. To top it all off, even the way these creatures move is kinda calculated. They don't just move randomly, but seem to gather together by species. We used to believe underwater animals behave this way only to avoid being caught by predators. It's a mystery to scientists why they group in the same way to form a fake seabed. Our curiosity about the deep waters doesn't stop at the seafloor. If you went on a vacation to the beach when you were young, you probably remember the fun of digging in the sand. As the hole got deeper, you may have asked yourself, could I dig all the way to the other side of the earth? None of us have ever found out. Our parents took us home when it got dark and chilly. Scientists are more reasonable when it comes to this subject. For starters, they know the best place to start digging would be underwater, since those regions are already deeper than what we can find on land. They also do not have the ambition to drill a tunnel through Earth. It's not even possible. That's mostly because of the extreme heat and pressure inside our planet. Even if we could technically dig a tunnel, it would not be safe to travel through it. However, reaching the mantle and retrieving a sample would be a huge scientific achievement, similar to landing on the moon. What we live on is called Earth's crust. Underneath it, there are other layers called the mantle, outer core, and inner core. Researchers have been trying to drill into Earth's mantle since the 1960s, but they haven't succeeded. Some failed due to technical issues, and others were unlucky and chose the wrong places to drill. Our planet's mantle is made of molten rock. Wouldn't that be dangerous if we ever reached it? Scientists say we have nothing to worry about, though. If and when the drillers eventually pierce through the crust underwater, hot molten rock won't pop up the hole and spill onto the seafloor like it would during a volcanic eruption. Mantle rocks aren't solid, sure, but they move slowly, at the same speed as your fingernails grow. Another of those famous deep-sea mysteries is that of the 1997 bloop. You heard that right. I'm talking about a weird sound that seemed to come from deep under the waves. People heard it in the South Pacific. No one had ever recounted a sound like that before. Some thought it must have been emitted by a strange creature living deep in the ocean. It didn't help that the noise came from a location mentioned in a story by famous writer H.P. Lovecraft. In his story, it was a creature called Cthulhu that lived there. In the novel, the author described it as a large, human-like monster with tentacles on its face and wings on its back. For many years, people tried to figure out where the noise came from. It wasn't until 2005 that they concluded it was from icebergs breaking off of glaciers. Some people still don't believe that this explanation truly makes sense and are searching for a different reason for the bloop. If creatures living outside of our planet ever decided to come to visit, you wouldn't expect them to go straight to the bottom of the sea, right? Well, some people claim there's a sort of spaceship on the ocean floor, discovered in 2011. It's basically an oval-shaped object located on the bottom of the Baltic Sea. In 2012, a team of divers explored the anomaly and found what appeared to be a staircase and other structures on its surface. This only added to the belief that the large object had been made by someone and wasn't just a natural phenomenon. Even more bizarre, close to the unidentified anomaly, the explorers' electrical equipment, like sonar instruments and satellite phones, started to malfunction. Some scientists believe it just to be a glacial deposit or some other natural formation, but they still don't know for sure what it is. A bridge, a very helpful structure that traces back to the Neolithic times. The oldest bridge in the world, at least the one that is still standing, is the Arcadico Bridge, built more than 3,000 years ago. But there's a river you cannot cross using a bridge, the Amazon River, the largest and longest river in the world. Okay, the Nile River is actually the longest river in the world, but the Amazon wants both titles for itself. The Amazon River is born in Peru and crosses Colombia and Brazil until it reaches a massive delta at the Atlantic Ocean. Its waters travel a longer distance than Frodo and Sam, and yet not a single bridge has ever been built over it. Why is that? First of all, seasonal floods change the size of the river. During dry seasons, the Amazon is about 3 miles wide, but during heavy rains, it can get up to 30 miles wide in a few weeks. Not only that, but the flood also makes the river change its position. Now imagine trying to build a bridge in a place where the ground turns into water for about 4 months. Not an impossible task, but not the easiest one either. Now, if you look back at your geography classes, you might remember that the soil of the riverbank can be very soft, especially in the Amazon, which means it can erode and shift. Heavy rains also create marshes, a type of wetlands that actually reduces the magnitude of the floods and purifies the water. It's also home to many animals. This means that to build a bridge, part of this wetland would have to be drained, which would ruin the lives of all those animals. Besides, the foundations of said bridge would have to be deep, and that would cost a lot of money. The rain creates yet another problem for the potential bridge. It increases the river's water level by 13 to almost 50 feet. Of course, bridges have been built in deep rivers before, like the Padma Bridge, a gigantic structure with a foundation of 417 feet. But because the soil of the Amazon River can erode easily, a bridge would have to be built using floating structures, known as pontoons, and they're not helpful in a river that changes depth whenever it feels like it. Next on our list of things that are a problem to human endeavors is the Amazon rainforest. This forest spreads over 9 countries and is so big and so dense it could cover about half of Europe. This means that a bridge would almost likely connect one patch of the forest to another. A pointless improvement to the lives of capybaras and jaguars. Of course, the real users of such a bridge would be humans. Most people live around the tributaries of the Amazon River, not around the river itself, because who wants to live like a beaver at a dam? There's even a state called Amapá on the left side of the Amazon River that is completely cut off from the rest of Brazil. You could easily take your car and visit its neighbor, a place called French Guiana. But if you wanted to go to another part of Brazil, you'd have to find other means of transportation. Aside from small riverside populations that live right on the riverside, of the Amazon, bigger cities were built near tributary rivers, like the Rio Negro, which has a bridge, by the way, and the Nanay River in Peru. The bridges that go over the Nanay and the Rio Negro are the only two bridges over the rivers in the Amazon basin. The lack of good roads and highways inside the Amazon also makes the creation of bridges a pointless endeavor. Back in the 70s, humans had big ideas on how to explore the Amazon ever more, which is why they decided to build a highway which would cut the Amazon basin from left to right. The road, called the Trans-Amazonian Highway, was supposed to bring people to the heart of the Amazon. But it seems like the difficulties of building more than 2,000 miles of road inside a dense rainforest were not foreseen. Halfway through, the project was abandoned because it was super expensive and problematic. Nowadays, highways in the Amazon basin are always flooded, filled with holes and mud. This whole situation creates a ripple effect. People don't live near the river because it's hard to access it. The roads don't go there either, because it's hard to build them. Which in turn makes even fewer people want to settle on the banks of the Amazon River, because they have no roads to get them there. So, if there are no roads and no bridges, how do people live there? You're not gonna believe this, but the riverside population uses a very old but reliable invention called a boat. The Amazon River is fully navigable, and the people that live there use it like a road. Much like motorcycles, cars, and buses, the Amazon River has canoes, speedboats, and ferries. There's even a very specific ferry called Obidense, transporting people to the municipality of Obidos, hence the name. Locals do everything on boats. They even have a boat hospital that floats around and visits riverside populations, and a boat bank, so you can do all your bank-related things while looking at the vastness of the Amazon. Honestly, genius invention. The downside to this lack of bridges is that it stops us from exploring the truly hidden gems of the world. In the Amazon, for example, there are over 10,000 undiscovered archaeological sites. We may never be able to dig out stuff like fortified villages, geoglyphs, and many other structures. It would be pretty neat to go full-on Lara Croft in the middle of the Amazon, but these findings are tucked deep in the heart of the forest. At the same time, only on a boat are you able to witness the crazy phenomenon of the unmixed waters of the Rio Negro and the Solimões on the Amazon River. For more than 3 miles, these two tributaries of the Amazon River flow side by side without mixing. The speed and the temperature of these waters are different, so you'll see a river that looks like coffee and Coca-Cola mixed. This awesome phenomenon is called the meeting of waters. But the Amazon River is not the only river in the world deemed bridgeless. The Congo River, the second longest river in Africa, only has one bridge crossing it. The two Congos, yes, there are 2 different countries in the world named Congo, are separated by the Congo River, and so far, no roads connect them. Also, fun fact, some geologists believe that back when Gondwana existed and the continents were all cuddled together, the Amazon and the Congo River were one river connected to each other. Another place with a lack of bridges is the east side of the Thames in London. The west side of the river is narrower, which makes building a bridge easier. There are about 33 bridges on the west side alone, but if you want to cross the river from the east side, it's gonna be a hassle. The thing is, back in the 1800s, shipping companies decided that building too many bridges over the Thames was too expensive, because this was a shipping route and the bridges would have to be taller than usual. The structure would also have to be long, since some parts of the Thames are about 1,870 feet wide. But building long bridges is not a problem per se. In Rio de Janeiro, for example, you can find the Rio Niterói Bridge, which is about 8.26 miles long. Back when it was built in the 70s, it was the second longest bridge in the world. The bridge is so long that in 2018, a girl was born while her mother was crossing it, and now the birthplace in her birth certificate is literally the bridge. There's also no U-turn on it, so if you drive onto the bridge by mistake, you're in for a long drive. So next time you feel like exploring the Amazon, remember to pack your own boat. If you've ever driven over the Rocky Mountains, you've probably seen road signs for the Continental Divide, the backbone of North America. All watersheds to the west of it run into the Pacific Ocean, and everything on its eastern slope goes straight into the Atlantic. There's just one creek in Wyoming that couldn't choose one side and drains into both oceans at the same time. Two Ocean Creek begins its journey high up in the Teton Range. The snow-capped peaks provide the perfect backdrop as the creek starts its descent, winding its way through alpine meadows and dense forests. As the creek continues its course, it gets to the Two Ocean Pass. This is the geographical crossroads where the creek splits into two branches, the Atlantic Creek and Pacific Creek. The Pacific Creek goes westward and becomes part of the larger Snake River watershed, bringing its waters to the Snake River, which eventually merges with the Columbia River and, finally, reaches the Pacific Ocean. The Atlantic Creek heads eastward and flows into the Yellowstone, Missouri, and Mississippi rivers, and eventually empties into the Gulf of Mexico. If you connect the two creeks' watersheds on a map, you'll get a single blue line between Oregon and Louisiana. Explorers struggling to find the Northwest Passage between the two oceans never knew they could have used the creek. They would just have to use really tiny boats. Some scientists believe that cutthroat trout had better luck in that way. They managed to migrate from the Snake River to Yellowstone River, most likely using the Two Ocean Creek. Technically, fish can travel over 6,000 miles to cover the whole distance from sea to shining sea in fresh water. The creek could be just perfect for that journey. There are hiking trails in Grand Teton National Park that lead to Two Ocean Pass. If you feel adventurous enough, you can stand at the literal crossroads of the continent and see the beginning of two aquatic journeys. Lonar Lake in India popped up literally out of nowhere around 52,000 years ago. Newer data says it could be much older, probably over 500,000 years. At first, scientists were sure that the lake was in an ancient crater of a long-extinct volcano. But then, geologists made a detailed analysis of the soil and water and found out that Lonar Lake has a space origin. The minerals found in its soil are similar to those found in moon rocks brought to Earth during the Apollo program. The lake is an impact crater left by a huge meteorite, which was almost 6 times heavier than the Empire State Building. The impact was so strong that the volcanic rock melted and turned into glass. In 2020, the lake, which was already unusual enough, suddenly turned pink. It wasn't a part of an early Barbie movie marketing campaign. The detailed analysis showed that the water contained an increased level of unique microbes. They accumulate on the surface and emit some pink pigment. After a while, the microbes settled to the bottom and the lake became transparent again. Flamingos that got their food from the lake also got to taste some of the microbes and became an even brighter shade of pink than usual. One of the most famous sights of Yellowstone National Park is the Grand Prismatic Spring. It's one of the largest springs in the world, and it's inspired people who have seen it since at least the 19th century. Back then, a group of trappers mentioned an indigo blue lake boiling like a huge cauldron. Decades later, expeditions came to the spring to study it better and explain its unusual appearance. But because the spring at its widest point is longer than an American football field, they had to build a special vessel and travel far from the shore. The scientists traveling in the boat never wore life vests. They knew those would be useless if the boat tipped over. The water in the middle of the spring is of near boiling temperature, and those vibrant colors are the result of extreme organisms living in the hot water. The temperature changes as you travel away from the center. Different species that don't mind the heat have settled in different parts of the pool, giving it its famous diverse pigments. Back in the early 20th century, someone got the interesting idea to try to irrigate a part of Nevada's Black Rock Desert. They drilled a well and found lots of water, but it was near boiling temperature. The water was clearly not good for agriculture, so the human-made geyser was left abandoned. Over the decades, it slowly turned into an impressive cone of calcium carbonate deposits. Then, in 1964, a geothermal energy company drilled another well close to the first one. The water they had found was of the same temperature. This time, it wasn't hot enough for their needs to produce energy, so they decided to cap the well and leave. But water managed to get up and out, and it completely dried up the first geyser. The second one, which got the name Fly Geyser, is still flowing burning hot water rich in minerals. The cone is multicolored and looks like it's not from this planet, thanks to the algae living in it, which love the heat. Every summer, Caño Cristales in Colombia turns into a liquid rainbow, or the River of Five Colors. At this time, and until the end of fall, the conditions are just right for the riverbed to turn bright red, yellow, green, blue, and black. We owe this beauty to certain aquatic plants growing in the river, a special type of riverweed. During the wet season, the river moves fast and the sun cannot get to these plants. During the dry season, there isn't enough water to feed them, so the time in between the seasons has the perfect conditions for this colorful show. It doesn't happen anywhere else in the world. At some point, the number of tourists who wanted to see it became so huge that scientists got concerned it could be bad for this hotspot of biodiversity. The area is home to rare species of animals, birds, and plants. Now, there are ecotourism trails and strict opening hours. In August 2014, a man in Tunisia was going back home from the north after doing his business. It was a hot summer evening, and he was dreaming about water, when suddenly, it popped up right in front of him. There was a whole lake in the middle of the desert, and the man was pretty sure it hadn't been there several days before. The new body of water got the nickname Mysterious Lake, and actually became a great mystery. Hundreds of people came here to swim in the clear, cool water. The lake became a popular place, but a few days later, the water turned dark green. The locals didn't care about this and continued to bathe in the lake. But when scientists and geologists arrived at the place, they announced that the water was dangerous to swim in. The lake was stagnating. It didn't refresh itself from underground streams, and the rains didn't feed it either. That's why the water became moldy and dirty. The lake contained algae and a lot of harmful bacteria dangerous to the human body. Scientists also found out that the land in this region had phosphate deposits. This substance can decay. But even that didn't stop people from bathing in the lake in the middle of the desert. How it got there remains a mystery. Some experts think that heavy rains have filled a hole in the ground with water. Another, more popular theory says that an earthquake had formed the lake. The seismic activity must have torn the Earth's crust above the water table, and then underground springs had filled the crevice. So, in theory, the lake could drain back out one day, just as suddenly as it had appeared.
The Amazon River travels through 9 South American countries at a length of over 4,000 miles. Still, it's impossible to cross it by a bridge. With the river being the main highway, traveling through this dense forest, and so few areas populated around the river, there's just no reason to have one. The river can rise up to 30 feet, and the river crossings that were only 3 miles wide can expand to over 30 miles in just a few short weeks in certain spots, making a bridge nearly impossible to build here. In New Zealand, in the coastal town of Mauriki, there are huge spherical boulders. Some rocks are 6.5 feet tall and weigh about 7 tons, as much as 10 cows. Ooh, there's a 10-cow boulder. Maori legend has it that these rocks are from the remains of the goods from a large shipwreck that happened hundreds of years ago. From a more scientific perspective, it's sand and gravel combined to form these giant boulders. Waves and winds give them a smooth, round appearance over time. The whole process might take millions of years. Indonesia's Kaiwan Ijen volcano is famous for a stunning turquoise-colored lake sitting at the top of the peak, but don't dip in. It's an acid lake. But its scariest part is the sulfuric gases leaking out when lava flows freely, reaching temperatures hotter than 1,000 degrees Fahrenheit. When those gases come in contact with the air, they combust into a spectacular electric blue flame. That's why the volcano has blue lava. The island of Surtsey, south of Iceland, was formed over 50 years ago by a volcanic eruption. It all began back in 1963 when a powerful volcanic eruption created one of the youngest islands on the planet. All sorts of bacteria, fungi, and molds began taking over the island, leading to numerous other animals finding their way here, like seals and birds. Birds and ocean waves deposited seeds all over the island. Sadly, the island's getting smaller now because of water and wind erosion. Located off the coast of Brazil, there's an island called… I'm a bit rusty on my Portuguese, so here it is on the screen. It looks perfectly untouched and pristine. Bad news? Dangerous snakes overrun it completely, so take a doctor with you in case you want to go there. Over 4,000 of the golden lancehead vipers inhabit this island. These 3-foot-long snakes are among the most venomous in the entire world. I think I'll skip that. Landing down under, you can see the Opera House, Uluru, lots of kangaroos, and catch the strangest wave of the world, Wave Rock in Western Australia. It's not made of water, but stone. It can be up to 50 feet tall and almost 300 feet long. It's especially incredible after rains in winter when the Western Australian wildflowers fill up the entire landscape. In Atlanta, there's a World of Coca-Cola museum. The formula for the secret recipe is in a large security vault, heavily guarded at all times. Only a handful of people can get through those vault doors. Since its creation in 1886, the company has kept it a secret for only the most honest employees. In 2006, a former worker tried to sell the formula to Pepsi, only for Pepsi to call the police and inform Coca-Cola. The Polka Dot Lakes is a must for anyone who is in British Columbia. After the summer's scorching heat evaporates the lake's water, it leaves behind yellow, blue, and green water spots. These pools are full of all sorts of minerals, like sodium, calcium, and magnesium sulfates that get concentrated in the pools. You can't get too close or even dip your feet into them. A fence protects the entire lake with a sign about how culturally and ecologically sensitive the area is. In Death Valley, California, there's a mystery of the sailing stones. Since the early 1900s, the mystery of how all these stones were seemingly moving by themselves across the desert floor baffled everyone. Some believe that the rocks move by thin pieces of ice around the stones pushed by winds after winter. No one ever saw any of these rocks moving until 2014. Scientists set time-lapse recorders, and the footage showed the rocks sliding along the ground over time. The marble caves in Chile, located in the beautiful area of Patagonia, formed from over 6,000 years of waves wearing down the rocks. The crystal blue walls reflect the vibrant turquoise water, making it perfect for kayaking. Walking in Chestnut Ridge Park in New York, one can see an eternal flame. What makes this one stand out, though, is it's underneath a waterfall. Occasionally, the flame will go out for short periods, but it will light up again. Sometimes it's thanks to certain hikers along the way. If you ever stop your car on a magnetic hill in New Brunswick, Canada, you'll see the car might start rolling backwards up the hill, all by itself. While it looks like it's moving the wrong way, this is just an illusion. There are several hills like this all around the world. What looks like an incline is the opposite, all because there's no horizon for perspective. The brightest bioluminescent bay in the world, called Puerto Mosquito, is located off the coast of Puerto Rico. The bay is named for the pirate Roberto Cofresi and his small boat El Mosquito, not after those annoying insects. During the summer months, you'll have glassy water at night with millions of tiny microorganisms bumping into each other and emitting blue light. The Chocolate Hills in the Philippines is a group of unusually shaped hills located in the middle of the island of Bohol in the Philippines. There are 1,000 to 2,000 discovered so far. They have nothing to do with chocolate at all, but they resemble the color after the dry season, when the grass turns from green to brown. In the northeastern part of Thailand, 466 miles away from Bangkok, is a 75-million-year-old rock formation sticking right out of the mountains. Their shapes look just like a pod of whales swimming together. No wonder this place is called Three Whale Rocks. Millions of years ago, this area was just a desert, but this land has changed quite dramatically during this time. These sandstone mountains were lifted up by plate tectonics, that's the shifting of the crust layers, called lithosphere, and erosion by the Mekong River, resulting in the strangely shaped rock formations we see today. Salar de Uyuni in Bolivia is the world's largest salt flat. At 4,050 square miles in size, it's twice as large as Grand Canyon National Park. After winter has passed, the salt lake is transformed into a beautiful giant sky-reflecting mirror between September and May. With salt all the way to the horizon, it creates an illusion of endlessness. The thin layer of water left over from ice melting creates a shimmering effect of the sky, making it one of the best places to visit in the world. The Catambo River in Venezuela might be the stormiest place in the world, with nearly 300 storm days a year. The lightning storms are so consistent, and they're predicted 3 months in advance. During the wet season in October, you might see 30 lightning flashes in a single minute. At sunset, strong winds flow around the 3 surrounding mountains, forming storm clouds over the water. When the water droplets of humid air collide with ice crystals from the cold air, the static charges cause a lightning storm that happens nearly every night. Off the southern tip of Japan lies the Yonaguni Formation. Archaeologists believe that the monument belongs to a fabled Pacific civilization, like Atlantis, that vanished beneath the waves thousands of years ago. If it's truly a lost civilization, or just nature having a little fun, this is the site to dive into. Features inside the structure resemble stonework like castles, temples, and a stadium, connected by roads and what seems to be large walls all the way around. There are even marks in the stone that appear to show quarry work, faded faces, and rocks sculpted into animal shapes. Some scientists believe that the symmetry of the stones is not as straight as reported. It appears solid rock rather than carved blocks, weathered down by all the water over many years. Plitvice Lakes National Park in Croatia is an interconnected chain of waterfalls, the tallest being 230 feet, and underground water channels, creating natural dams and lakes in such a picturesque environment. Found in the deep woodlands surrounded by meadows brimming with wildflowers, brown bears, gray wolves, lynx, deer, and plenty of rare bird species for birdwatchers call these 115 square miles of the national park home. A tsunami hitting major cities on or near the Mediterranean Sea and in the northeastern part of the Atlantic Ocean is not a matter of if, but when. It is scary and surreal to think that places like Cannes or Barcelona could suddenly get slammed by a huge wave. But the fact is, European coastlines are in active tectonic areas. Only about 10% of all tsunamis worldwide happen in the Mediterranean, and there have been at least 290 tsunamis in this area since 1600, before Common Era. Despite the relatively low number, this phenomenon has caused numerous devastating disasters throughout Europe's history. Back in 1755, an estimated 8.5 magnitude earthquake, with an epicenter southwest of Cape St. Vincent, triggered a tsunami that destroyed most of Lisbon, the capital of Portugal. About 40 minutes after the earthquake, this massive wave just slammed into the harbor in downtown, racing up the Tagus River. The phenomenon was so fast that several people on horseback had to gallop to higher ground to avoid getting carried away. And this was just the beginning of a nightmare, with 2 more terrifying waves hitting Lisbon right after. A disaster like this is similar to what we see in the Pacific Ocean several times a century, but in the Atlantic, it's very rare. This type of major tsunami is expected to happen every 3 to 5 centuries, but now it could happen tomorrow. Marseille in France, Chipion in Spain, and other cities are on the list of important locations that could be flooded soon, with a roughly 100% chance of being hit by a tsunami in the next 30 years. Statistics show that the wave will probably be more than 3 feet high. I know, it doesn't sound like much, especially since when we think about tsunamis, we imagine terrifyingly tall waves, like the one that hit Lituya Bay in Alaska. In that case, the wave was over 1,700 feet tall. But we must remember that even waves only 19 inches high can be dangerous to swimmers. Because it's not the height of the tsunami that matters, but also the flow and movement of the water. Not to mention the flooding, which can damage beaches, harbors, and streets. If the coastline has a small harbor and the waterfront is exceptionally low, like Cannes, this natural disaster might be much more dangerous. Tsunamis around 6 feet high can lift cars off the ground, while smaller waves can create walls of water traveling at 40 miles per hour. Plus, there are these smaller events that might not wreck everything, but still can cost a ton of money. For example, large sandbars that move around on the ocean floor, like sand dunes shifting in deserts. They can mess up pipelines or deep-sea cables for internet and communications, and that ends up costing businesses and governments millions of dollars. That's why organizations like UNESCO are worried about the possibility of a dangerous tsunami hitting Europe soon. So they're doing everything they can to prevent apocalyptic scenarios, like what happened in 2004 when an earthquake off the coast of Sumatra, Indonesia, caused waves over 100 feet high in coastal communities, resulting in over 200,000 lives lost. And let's not forget about 2011, when an earthquake off the coast of Tohoku, Japan, triggered a tsunami that reached about 6 miles inland and caused a major nuclear accident at a power station along the coast. Over 16,000 people lost their lives in that tragedy, and the event resulted in billions of dollars in infrastructure damage. These disasters were huge wake-up calls, and we've come a long way since 2004. We're much safer today, largely because the tsunami warning system is highly effective at quickly detecting this dangerous situation. Unlike many other natural phenomena, a tsunami can be anticipated. We may only have a few minutes to act, but if we all know what to do, many lives can be saved. And in most parts of the world, sirens are commonly used to alert people to tsunamis. To sound the siren as early as possible, initial tsunami alerts usually rely only on seismic data. First, specialists receive information about an earthquake. Seismic waves travel about 100 times faster than tsunamis, so they have enough time to analyze the data and see if the earthquake might have generated a tsunami and whether they should issue an initial tsunami alert. At U.S. warning centers, for example, scientists typically issue initial alerts within 5 minutes of an earthquake. If a tsunami is suspected, these alerts may also include information about wave arrival times, recommended actions, and potential impacts. But sounding the alarm is not enough. To save lives, coastal communities also need to be trained to respond fast and in the best way possible. That's why UNESCO produced this program called Tsunami Ready, aiming to train people living in coastal areas at risk on how to act in case of a tsunami event by the year 2030. The idea is to help communities stay safe by teaching them how to protect their livelihoods and safeguard their homes. Being recognized as Tsunami Ready by UNESCO doesn't mean a community is tsunami-proof, of course. It's more like a recognition that they have adopted all possible measures to mitigate tsunami risks. So authorities are helping communities to prepare themselves by installing evacuation signs, establishing security procedures, and creating plans to warn tourists. Like Spain, which distributed tsunami warning signs along the entire coastline, as well as signs showing evacuation routes to higher ground. And Spain better be prepared. I mean, only 7 tsunamis have hit the country since the year 365, so it's difficult to predict the effects of such an event. But they could be devastating, considering that Spanish coastal areas are so economically important. There's also a danger zone in the Averroes Fault, beneath the Boran Sea. If an earthquake happens at this point, people will have only 21 minutes to escape a tsunami. UNESCO has also established 12 tsunami warning centers, which cover Europe as well. This initiative involves 5 centers located in the Mediterranean and Northeast Atlantic regions. These centers can save thousands of lives because they monitor ocean disturbances 24/7. Then, after analyzing the threat, they send out messages based on the event's potential to cause a tsunami. The intensity scale ranges from no effect to completely devastating. And by that, they understand that nearly all brick buildings could be demolished by waves, and even the most reinforced concrete structures could suffer heavy damage. Now, so far, we have mostly talked about tsunamis caused by earthquakes along converging tectonic plate boundaries. In fact, earthquakes have accounted for over 80% of tsunamis since 1900. But tsunamis can also result from landslides, volcanic eruptions, and even meteorite impacts. Experts are also worried that with the current changes in climate, we might see more of meteotsunamis popping up in the Mediterranean. These ones are triggered by freaky weather conditions and can mess with any coastline that's got a shallow seafloor. They might not be as huge or famous as the earthquakes ones, but they can still cause significant property damage and put people in danger. For instance, in 2006, a meteotsunami struck the harbor of Ciutadella on the Spanish island of Menorca. Yachts were tossed into each other and later stranded on the harbor floor as the water receded, resulting in tens of millions of euros in damage. Unfortunately, meteo tsunamis in the Mediterranean tend to be stronger during summer, so if you're planning to spend your vacation in Europe, stay alert for any signs of dangerous waves. If you suddenly encounter a tsunami moving in your direction, remember this is the time to react. Move to higher ground as far inland as possible. Pay special attention to any emergency alerts and information, and follow the guidance of local authorities. Most importantly, do not wait around taking photos. Leave the area as soon as you notice any signs of this danger event, or if you hear an official tsunami warning. Hey, stay safe. An underwater earthquake opens a huge gap in the ocean floor. A large volume of water moves to fill the crack. At the same time, waves start to spread out from that point. They're just a foot high at first, but the closer they get to shore, the larger they become. When the waves reach shallow waters, they start to slow down. Their lower parts get to dry land first. This creates a vacuum effect that pulls the water away from the coast. The harbor and seafloor are visible now. And then, an enormous wall of water hits the shore. It wipes out everything in its path. Several minutes later, more waves usually arrive. Or it can be a landslide happening near a large body of water. Enormous amounts of forest, soil, and rock roll down into a lake or ocean, producing huge tsunami waves. Volcanic eruptions are responsible for 5% of the world's tsunamis. They can move great volumes of water and generate really big waves. Some tsunamis are caused by meteorites striking into our planet. If one of these red-hot space visitors strikes the ocean, the force of this collision displaces enough water to produce an extremely powerful tsunami. When a tsunami starts, its waves are usually just 1 foot high. That's what a small wave looks like. It comes up to the waist of the average person. Surfers call such rather big waves double overhead. The largest earthquake ever recorded happened near the coast of southern Chile. It triggered a tsunami that reached Hawaii, Japan, and the Philippines. The tsunami's largest wave was as tall as a 5-story building. The largest wave ever surfed was half as tall as the Arc de Triomphe in Paris. Garrett McNamara set this record in 2011 in Nazaré, Portugal. In 1995, scientists proved the existence of rogue waves, sudden unexpected swells. On that day, they saw an 84-foot wave. It was taller than the world's largest passenger plane Airbus A380. The giant was surrounded by smaller 20-foot waves. Tohoku tsunami waves in 2011 were generated by the strongest earthquake in Japan's recorded history. The highest wave was almost half as tall as the Brooklyn Bridge. Krakatoa's volcanic eruption in 1883 produced the loudest sound ever heard on the surface of the planet. The highest tsunami wave the eruption formed was as tall as the Statue of Liberty. April Fool's Day tsunami in 1946 was triggered by a powerful earthquake near Alaska. The tsunami's highest wave was a bit taller than the Colosseum in Rome. The Boxing Day tsunami started in the Indian Ocean in 2004. It was caused by a powerful undersea earthquake. Its tremors produced a series of tsunami waves. The largest of them almost reached the height of the Leaning Tower of Pisa. One of the most disastrous landslides hit Lodoland Valley in Norway in 1936. An enormous piece of rock, almost twice as large as the Eiffel Tower, broke loose and hurtled into Lofoten Lake. This caused an enormous tsunami wave. It was almost as tall as the Taj Mahal in India. 2017 Greenland megatsunami was triggered by a massive landslide at one of the fjords. The waves that flooded the shore reached the height of Big Ben. A powerful volcanic eruption caused a landslide from a 4,000-year-old lava dome. This set off Unzen volcano megatsunami. The largest wave was half as tall as the Space Needle in Seattle. Fogo megatsunami happened 73,000 years ago, when a part of the Fogo volcano collapsed into the sea. The megatsunami's largest wave was as tall as the Washington Monument. When the upper 1,500 feet of Mount St. Helens exploded, it caused a massive landslide. A part of this avalanche plunged down into Spirit Lake. This caused a wave that was more than half the height of the Eiffel Tower. The Vajont Dam megatsunami happened when a landslide dragged 9 billion cubic feet of forest, soil, and rock into the lake. A colossal wave overtopped the edge of the dam, taking out everything in its path. Its height was greater than that of the Golden Gate Bridge. A landslide in Lituya Bay in Alaska formed a megawave, one of the largest ever recorded. The megatsunami surged over the headland, washing away trees, plants, and soil down to bedrock. The wave reached more than half the height of the Burj Khalifa, the tallest construction in the world. A third of the East Molokai volcano in Hawaii caved in and collapsed into the Pacific Ocean. This created a tsunami the size of the second tallest building in the world, Shanghai Tower. The strongest earthquake ever to strike east of the Mississippi River that happened over 200 years ago was never over, according to some scientists. Most earthquakes last seconds to minutes, and the official record breaker so far is a silent one in Sumatra that was going on for 32 years. This slow slip event triggered a massive quake and a tsunami. So if it's true that the New Madrid earthquake is still sending aftershocks, we'll have a new top name for this sad list. The earthquake started in December of 1811 with a powerful quake in a sparsely populated part of northeast Arkansas. They felt the shaking almost 1,000 miles away in the White House, and the tower bells were ringing in Boston, even further away. It even made the mighty Mississippi flow backward for a few minutes over new waterfalls formed by shifted ground. The town of New Madrid, Missouri, completely disappeared in the disaster. The Earth wouldn't stay still until the end of January the following year, when things got serious again. A massive quake hit, this time near the junction of the Ohio and Mississippi rivers, right in the Missouri boot heel. Geologists believe it was a rupture on the New Madrid Fault, putting even more strain on the nearby Reelfoot Fault. Just when people thought it couldn't get worse, another 2 weeks of trembling passed, and the Reelfoot Fault snapped deep beneath New Madrid. Down in Tennessee, about 15 miles south of New Madrid, the ground uplift created Reelfoot Lake. Steamboats were chugging along the river, with thousands of trees floating and acres of woods torn apart by the quake. In St. Louis, Missouri, which is 160 miles away, buildings were badly damaged, and chimneys fell in Cincinnati, Ohio, 400 miles away. People all the way in Montreal, Canada, over 1,000 miles away, felt the earthshake. Seismologists have registered about 200 small earthquakes in the New Madrid seismic zone every year since 1974. Some researchers believe that up to 30% of those were aftershocks from those big quakes back in 1811 and 1812. In parts of the U.S. where there's not much tectonic action going on, these aftershocks could keep rumbling for years, maybe even centuries after the big ones hit. Aftershocks are the Earth's way of releasing all that built-up stress from the main quake. When the ground shakes from the first earthquake, it puts a lot of pressure on the rocks nearby. And when those rocks can't take it anymore, they crack, causing even more shaking. That's the aftershock. And they can be pretty intense, especially right after the main quake, but weaken over time. Not all scientists agree that contemporary earthquakes have to do with those from 200 years ago. We mostly associate faults with those lines where Earth's plates meet. But there's a whole network of those right under the center of the North American plate. They're like relics from 750 million years ago, when North America was part of a supercontinent called Rodinia. When Rodinia started to break up, it left behind these rifts, weak spots in the Earth's crust that run deep beneath the modern Midwest. It could explain the earthquake action. An international team of geologists decided to take a fresh look at 3 major earthquakes that shook North America and end the debate. They used a new math method called the nearest neighbor. It says that if earthquakes are too close in space, time, and magnitude to be independent background events, then one is assumed to have triggered the other. Depending on how you look at the numbers, somewhere between 10 to 65% of the recent quakes in the region could be aftershocks of those historic earthquakes. And a huge quake that hit Charleston, South Carolina at the end of the 19th century might explain up to 72% of the earthquakes in the area since then. But not all places are the same, so the scientific debate continues. In 1774, British explorer James Cook noticed a glow in the distance. It was the volcano of Mount Yasur in Vanuatu. This bad boy had been spewing lava and ash ever since, and it's quite likely that it's been doing that for way longer. The volcano has been sitting at alert level since October 2016, which means things are really unsettled around there. They've even marked off a 2,000-foot radius around the crater to keep people safe. There have been low to moderate outbursts, shooting out ash, gas, and steam, and some bigger blasts throwing stuff outside the crater. Satellite images have picked up on some hotspots of sulfur dioxide plumes, showing that Yasur is still cooking up a big storm down there. Stromboli, one of the volcanic islands near Sicily, officially has the Guinness World Record as the longest continuously erupting volcano. It has been putting on a fiery show for over 2,400 years straight. Ancient sailors nicknamed it the Lighthouse of the Mediterranean. Most of the time, Stromboli's just spitting out spatter, but every now and then it throws in some lava flows or shoots up some moderately high fountains. Sometimes you might even catch a glimpse of steam-driven outbursts. Over 200 million years ago, the world went through a major makeover, with not one, not two, but 4 massive volcanic eruptions changing the game. It all happened in Rensselaer, a large chunk of island that used to be a supermassive volcano stretching across what's now British Columbia and Alaska. This volcanic activity might have helped dinosaurs grow from cat-sized critters into giants we saw in Jurassic Park. It kicked off a 2-million-year rainy season. It made the whole world hot and humid, and the dinos just loved it. Researchers dug deep into sediment layers beneath an ancient lake in China to uncover these secrets. They found traces of volcanic ash and mercury, clear signs of those epic eruptions. There were carbon signatures showing huge spikes in carbon dioxide levels, making the atmosphere toasty and the rain pouring down. It all happened in 4 separate pulses, each triggered by those monstrous volcanic blasts. There's a spot in a national park not too far away from Sydney, Australia, where a fire has been raging deep underground for at least 6,000 years. They call it Burning Mountain, and it's a coal seam fire, burning its way through a layer of coal beneath the Earth's surface. Once these underground fires start, they're pretty much impossible to put out. This ball of fire is up to 30 feet wide and extremely hot, but there's no flame, it's smoldering. The fire has been creeping along at a pace of about 3 feet per year. A local farmer first spotted it in the 19th century and thought it was a volcano. The people who have lived here for ages believe this place is sacred. They've used it for cooking and crafting tools, and tell that it started from a widow's tears or the torch of a hero. But experts think it could have been a lightning strike or coal heating up like a summer barbecue from the interaction with oxygen. Some say it might have been burning since before the dinosaurs roamed the Earth. No one knows exactly how long this mountain will burn or in what direction it'll move. Right now, the coal has enough oxygen to burn for centuries or even millennia without human intervention. The fire is heating up the mountain like a giant oven, making it crack and crumble, inviting in more oxygen to feed on. Even if humans decide to take action, these coal seam fires need truckloads of water and liquid nitrogen to tame them. Several years ago, explorers noticed that the smolder was creeping close to a cliff overlooking a little river. And depending on what the coal seam decides to do next, we could see some dramatic changes here in the coming decades. There could be flames with much more heat, or the coal seam could go deep, extinguish itself, and smolder out. Ah, Phoenix. This sizzling gem in the Sonoran Desert isn't just another American city. It's more like a giant oven where you can throw a party, as long as you don't forget the ice. Seriously, if you find yourself here in the summer, brace yourself for some serious heat. We're talking about temperatures that regularly pass 100 degrees. And in 2024, Phoenix hit 110 degrees 55 times during the summer, tying the record set just the year before. Now, I get it if you're not a fan of hot weather, but apparently a lot of people love living in a sauna. Phoenix ranks as the 5th largest city in the United States, and it is the capital and most populous city in Arizona, with 1.7 million residents as of 2024. And if we're talking about the metropolitan area, also known as the Valley of the Sun, the population is almost 5 million. Yet, good luck finding someone actually born here. Out of every 4 Phoenix residents, 3 were born somewhere else. Believe it or not, Phoenix wasn't always this bustling, crowded place. It became one. A few decades ago, it was just a sleepy little dot on the map. Back in the 1940s, the population was around 65,000. It wasn't even close to cracking the top 100 list of the largest U.S. cities. Now, at that time, Phoenix was mostly an agricultural hub, and its economy revolved around what they called the 5 C's: cotton, citrus, cattle, climate, and copper. But things really started to change in the 1950s thanks to one life-changing invention. Drumroll please? The air conditioner. Actually, it was the portable version that came out in 1945, created by an American inventor named Robert Sherman. Phoenix residents owe a lot to Robert for making life bearable during scorching summers. Before AC, people in Phoenix would literally move their beds outside and build sleeping porches. They'd protect that kind of outdoorsy space with light curtains or some kind of net to keep the dust and bugs out. Fun. Anyway, the point is that the air conditioner played a big part in making Phoenix an easier place to live. Since the 1940s, this city in Arizona has transformed from a dusty little town into a sprawling urban jungle, and it's still one of the top 10 fastest-growing metro areas in the U.S. The best part is, it looks like that won't change anytime soon, since this 519-square-mile metropolis is surrounded by rolling desert, with plenty of room to keep growing as far as the eye can see. So, who's dropping everything to move to Phoenix? Well, Californians are the city's biggest fans. According to a recent survey, a third of all new renters moving to Phoenix come from Los Angeles. Okay, that survey might not be the most reliable since it only applies to the source's clients, but it does line up with U.S. Census Bureau data from 2019, which says that 70,000 Californians moved to Arizona in the previous year. The connection between Phoenix and LA is so strong that some people even call Phoenix the next LA. You've got to give Phoenix credit for capitalizing on its proximity to Southern California. The city offers lower taxes, fewer regulations, and lower costs of living, which makes it a magnet for businesses, especially in high-tech and service industries. So, in the 90s, Phoenix was considered a non-stop generator of jobs. In the last few years, we've seen the number of jobs only go up, and the unemployment rate has dropped by nearly half, going from 6.3 in January 2014 to 3.4 in the same month in 2024. Now, when it comes to big city problems, you can't avoid talking about traffic. But here's another reason why Phoenix is a dream city. It doesn't even come close to the traffic nightmares you find in places like LA. Estimates show that people in Los Angeles waste about 119 hours a year just sitting in traffic. But in Phoenix, it's more like 61 hours. Huge difference, huh? And let's not even start talking about the money people waste just sitting in traffic. In LA, drivers burn through about $2,440 worth of gas per year. In Phoenix, they waste 25 gallons of fuel, which ends up costing about $952. Yeah, that's still a lot of cash, but compared to LA, come on, that's a steal. Phoenix being okay in terms of traffic might have a lot to do with how the city was designed. Just take a look at a map of Phoenix. You'll notice it looks like someone took a ruler and drew perfectly straight lines for the roads. That's because the city was laid out in a grid system. This setup makes it so much easier to get around, especially compared to cities full of confusing twists, U-turns, and one-way streets. It just simplifies things, whether you're a local or a tourist. Plus, Phoenix has nice wide streets. Most cities have one major road and a bunch of narrow streets that just can't handle heavy traffic. But Phoenix has wide roads everywhere. So, when the freeways get jammed, you can just hop onto a parallel street and still get to work without stressing out too much. When you look at all the job opportunities and the relatively smooth traffic, it's no wonder people are willing to put up with the heat and move to Phoenix. But don't get it twisted, the heat is no joke. It is really, really hot and sunny out there. We're talking about 300 days of sunshine on average, or about 85% daylight hours per year. But once again, Phoenix has made the best of it. And all that constant sunshine has turned Phoenix into one of the top solar energy cities in the country. Now, you may be wondering, a city in the middle of the desert with barely any rain, do they actually have enough water? Well, they do. Phoenix has its water situation pretty well sorted out, thanks to multiple sources. I mean, they don't rely on rain alone, which is a good thing because, desert life. Most of their water comes from way up north and east of the valley, where snow melts off the mountains and flows into giant reservoirs, storing it up for those dry years. But most of Phoenix's water comes from the Salt River Project, which brings water through canals and pipelines from the Salt and Verde rivers. Then there is the Central Arizona Project, which transports water all the way from the Colorado River. They even get a bit of water from underground wells. And Phoenix doesn't want to waste a drop, so they're smart about recycling, reusing treated water to keep parks green, and even recharging their groundwater. Since Phoenix is all about sunny skies nearly every day of the year, it's normal that people can get a little moody when it actually rains. But here's the thing. Phoenix always gets a surprise up its sleeve, even when it comes to bad weather. When it rains in the deserts, locals get treated to this unique earthy smell. It's thanks to the creosote bush, a desert plant that releases an amazing fragrance when the rain hits it. People describe it as the smell of rain, and honestly, it's one of those fresh, clean scents that makes you forget you're in the desert for a second. And if you've never stopped to think about why Phoenix is called Phoenix, well, it's based on that famous legend of the bird that rises from the ashes. Now, after knowing all the special things about this city and its unique ability to turn challenges into advantages, we can say the name couldn't have been better chosen. About 800,000 years ago, I wasn't around then, a gigantic asteroid soared through space and plummeted toward Earth. It slammed into our planet with enormous force. It blanketed 10% of Earth with shiny black and green lumps of rocky debris known as tektites. Tektites are pieces of rock that get liquefied by the heat of a meteorite impact. Then they cool down to look like dark, glassy pebbles. A trail of these tektites was strewn across Southeast Asia and reached all the way to eastern Antarctica. This is how scientists know this giant meteorite crash happened. Well, researchers spent nearly 100 years trying to find the gigantic crater caused by the impact. But tektites were too widespread. That's why they couldn't pinpoint the exact location. Until recently. A team of experts from different universities tried to discover the ground zero of the meteorite impact. They investigated several craters in China and Cambodia, but none seemed to be created by a meteorite crash. The experts then decided to investigate Laos. It's a country where they discovered the largest and most concentrated number of tektites. After ruling out all visible craters, the team came up with a new theory. What if the crater is hidden by something? In search of the potential crater, the scientists measured gravity readings at different locations all across Laos. At the site of an ancient volcanic eruption, below thick, dense layers of cooled volcanic lava, they discovered a severe gravitational anomaly. It turned out to be a large, elongated crater, over 300 feet deep and spreading 8 miles wide and 11 miles long. Based on the location and the crater's enormous size, scientists believe this is the impact site of the ancient meteorite. Meanwhile, over 2 billion years ago, long before the age of dinosaurs, Earth was struck by one of the largest asteroids to ever hit our planet. The asteroid was approximately 6 to 9 miles across and created the biggest impact crater on Earth. This is the Vredefort crater. You can find it in present-day South Africa. When it was formed, it had a gigantic diameter of 186 miles. Over the centuries, the massive crater slowly eroded away into the Vredefort Dome. That's a rocky hill formation that was the central site of the asteroid's impact. This formation is so large that it can be seen from space. Today, the Vredefort Dome is a recognized World Heritage Site. It's also home to several towns and communities that encourage tourists to come and visit the ancient crater. In 1943, one pilot strayed from his regular flight path to avoid dangerous weather conditions. Flying over Quebec, Canada, he spotted a large, perfectly circular basin. That is how the Pingualuit crater was discovered. Around 1.4 million years ago, a meteorite hit this spot, creating this small but deep impact crater. It has a diameter of 2 miles and a depth of 1,300 feet. A lake of deep blue water has formed at the bottom of the crater. It's said that this lake contains some of the purest water in the world as it has no inlets or outlets. It means that the lake is only filled by rains and melting snow. The lake is home to one species of fish, the Arctic char. The Sudbury Basin is also in Canada. Formed over 1.8 billion years ago, it's one of the largest and oldest impact craters in the world. It's located in Ontario, but the impact from the collision was so powerful that debris from it was found 500 miles away in Minnesota. Unlike most impact craters that have a circular shape, the Sudbury Basin is an oval. It's 39 miles long with a width of 19 miles. The original impact site might have been a whopping 10 miles deep, but its modern-day version is much shallower. The asteroid that created the basin carried a high concentration of natural minerals. This made the soil in the crater incredibly fruitful. Today, its floor is home to numerous fruit and vegetable farms. The unique crater formation of Sudbury Basin was used to train Apollo astronauts before they embarked on their missions to the Moon. Perhaps the most famous meteorite of all is the Chicxulub. That's the meteorite responsible for wiping out 75% of all plant and animal life on Earth, including the dinosaurs. The Chicxulub meteorite had a diameter of 6 miles when it struck Earth 66 million years ago. The crater now lies off the coast of Mexico, hidden deep beneath the seabed. It's around 93 miles across and 12 miles in depth. Recently, scientists managed to drill deep down into the highest peak of the impact crater to collect rock samples. They discovered that the disappearance of dinosaurs wasn't caused by the giant size of the meteorite or the scale of the blast. It was because of the exact location where the Chicxulub hit Earth. The meteorite struck part of our planet that was densely filled with a mineral compound called gypsum. It's a soft sulfate mineral that is typically used as a fertilizer. The collision blasted so much sulfur into the air that it blocked out the sun. This caused the prolonged dark winter that doomed the dinosaurs. One of the youngest craters on Earth is the Barringer crater in Winslow, Arizona. The Barringer crater is also one of the best preserved craters on Earth. It was formed 50,000 years ago when a heavy meteorite made mostly of iron plummeted down from space. Earth's atmosphere barely slowed down the massive chunk of metal. It collided with the ground with incredible force. The meteorite vaporized upon impact, leaving very few remains. The crater left by this powerful explosion was named after the man who identified it in 1903. It was a mining engineer named Daniel Barringer. The diameter of the crater is 3,900 feet and it goes 560 feet deep. The Barringer family still owns the impact site to this day. You can visit the crater and take a guided tour around its rim. The Papagai crater in Siberia is one of the most interesting craters on Earth. An asteroid impact over 35 million years ago formed this massive basin. The crater is 62 miles across, which makes it the fourth largest one in the world. This crater is unique as it's home to one of the largest diamond deposits in the world. The intense pressure from the collision transformed the graphite at the impact site into diamonds. Scientists say that the crater contains trillions of carats of diamonds, but no one has ever mined them due to the site's remote location and lack of infrastructure. In the year 1530 BCE, a meteoroid entered Earth's atmosphere before shattering into pieces. The meteorite's burning fragments rained down on Earth and crashed into the planet's surface. As a result, a group of craters appeared on a small Estonian island, Saaremaa. The largest crater is a 360-foot wide perfect circle. It's 70 feet deep and filled with blue water. 8 smaller craters that appeared during the collision can be found within a half-mile radius of the largest crater. The impact of the meteorite fragments caused the trees on the islands to catch fire. almost all forests burned down. Luckily, the woodlands have now grown back, and the craters are a popular hiking destination for tourists. A meteorite struck the area we now know as Quebec, Canada, around 200 million years ago. This collision created the sixth largest impact crater in the world. It had a diameter of 40 miles. Over the century, the outer rim of the crater has filled up with water. It's now known as Manicouagan Reservoir. The impact crater lake is so large it can be seen from space, and its strange shape gave the lake its nickname, the Eye of Quebec. The oldest meteorite crater in the world is in Western Australia. The Yarrabuba crater is 2.2 billion years old. Well, that gets my vote for the best crater name. The impact site is so ancient that the original crater has completely eroded away. Yarrabuba's diameter was around 19 to 43 miles. Scientists managed to figure out the age of the impact site by analyzing the ancient crystals and minerals found within the crater. If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now, normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these 2 being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable, as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger.
A magnitude 15 earthquake has the potential to completely destroy our planet and evaporate all the water in a matter of seconds, leaving Earth uninhabitable. Over 500,000 earthquakes happen annually, but none have a magnitude of 15. 90% of quakes occur in the terrifying Ring of Fire zone located around the Pacific Ocean. The ground there is like jello. It shakes almost constantly. The most powerful earthquake to have ever struck Earth had a magnitude of 9.5. That much power can lengthen or shorten the day. But there's probably an earthquake in the confines of your own home now caused by a speck of dust landing on a table. But it has a power of negative 15 magnitudes. Earthquakes happen when tectonic plates move. They're like Lego pieces that are not properly secured, and when they move up, down, or hit one another, the ground also moves, triggering earthquakes. This tectonic energy acts like a battery. It stores energy for a long time, up to 500 years. When this stored energy is released in a sudden burst, the consequences are horrifying. Even the strongest structures submit to this relentless force that leaves a trail of destruction in its path. In some instances, earthquakes can even trigger tsunamis, amplifying the chaos. Such a crazy amount of power can split the ground open and cause severe damage. The strength of an earthquake is measured by the Richter scale, but now it's being replaced by the moment magnitude scale. When there's an earthquake, we hear about how strong it is. It's usually from 1 to 10. Luckily, we haven't had a Richter scale earthquake yet. The most powerful earthquake to have ever happened in modern history occurred in Chile in the 60s. It was around 9.5 on the Richter scale, and it altered Earth's rotation and messed up the length of the day by around 2 milliseconds. It also triggered a massive tsunami and affected a vast area of 155,000 square miles. The Richter scale doesn't actually have a limit. Still, anything above 25 doesn't need measuring, because if that ever happened, we would simply turn into dust, and nobody would care to measure this disaster. As we said, the strongest earthquake had a magnitude of 9.5. If this magnitude had been just 0.5 stronger, it would have created a ruptured line 2,174 miles long. That is almost 7 times the size of Wyoming. A magnitude 11 earthquake would create a crack halfway around the world. Massive tsunamis would hit coastal areas, destroying everything, and Earth would get into a massive environmental crisis. If you love hiking, you would have new mountains to explore, created by the terrifying earthquake. Even the temperature would increase because of volcanic eruptions and the resulting greenhouse gases. It would turn our planet into a hot oven. The safest places would be far away from any buildings, seas, oceans, and mountains where there would be a low chance of a landslide. Countries unprepared for earthquakes would be totally destroyed, and cities would turn into piles of rubble and dust. Going up on the Richter scale would only make things worse. But don't worry, an earthquake of that power is impossible. Earth's crust doesn't have enough energy to produce such earthquakes. But there is something that has much more power and can produce mega earthquakes. Asteroids are powerful enough to destroy our planet, as we all know from the dinosaur era. That asteroid was around 6 miles long, and it caused massive damage to the planet. It triggered earthquakes that shook the ground constantly for months. These terrifying quakes were about 50,000 times stronger than the Chile earthquake. They also triggered a tsunami that was 30,000 times more powerful than the Indian Ocean tsunami. And the latter was one of the most devastating tsunamis to have ever struck Earth. The earthquakes caused by the asteroid had a magnitude of 11, making it the most powerful and scariest natural disaster ever. And let's hope it stays that way. The Indian Ocean tsunami affected only certain areas of the world. Meanwhile, the asteroid tsunami affected every part of the world and had 33-foot-tall waves. Even if you had traveled to the most remote place on Earth, you wouldn't have been able to hide from this Grim Reaper. A 15 magnitude earthquake wouldn't be 15% stronger than the Chile earthquake. The scale doesn't work like that. It would be around 100 million times more powerful than a 9.5 magnitude quake. It could make all the water on Earth evaporate, leaving us devastated and without any H2O to survive. All ecosystems would collapse, all food chains would be broken, and only some super strong bacteria would probably survive the impossible. That is only a fraction of the frightening things that could happen. The ocean is like the AC for our planet. Without it, Earth would be super hot. The ocean also serves as a shield from the sun's powerful rays. It acts as a heat absorber and cools Earth. Scientists think that the most dangerous thing would be the inability of Earth's crust to survive the violent shakes of the 15 magnitude earthquake. If our planet miraculously survived and didn't turn into dust, there would be massive openings in its crust. The ground would become gelatinous. It would randomly move up, down, left, and right, and no building would survive that. Our civilization would be brought back to the Stonehenge era. Tectonic movements like this are devastating. A similar thing happened in Japan when tectonic plates moved 165 feet from each other and then snapped back together, creating a 9 magnitude earthquake. No place on Earth is immune to this bone-chilling natural phenomenon. Still, certain places have higher chances of being destroyed than others, like the Ring of Fire, where 90% of earthquakes happen. This is a place where earthquakes are almost everyday occurrences. The Ring of Fire is located in the Pacific Ocean. It forms a ring around the continents that surround the Pacific. There, several tectonic plates meet, creating highly unstable ground. To make the problem much more terrifying, 75% of active volcanoes are located in this area. 90% of dormant volcanoes are also there, making this place extremely dangerous. Scientists carefully study this region to find a way to predict when the next earthquake might strike. The Ring of Fire is not the only place at risk of earthquakes. In California, along the San Andreas fault line, 2 tectonic plates have been storing power for more than 200 years. The San Andreas Fault is 715 miles long and has the potential for a massive earthquake. This region has its fear of violent earthquakes like the one that happened in San Francisco in 1906. It had a magnitude of 7.8 on the Richter scale. Scientists' predictions are terrifying. They say that the chance of a 6.7 magnitude earthquake is very high in the area. If all hell starts to break loose, you should know how to survive. Avoid anything that might fall on you, like windows, closets, or unstable ceilings. The official phrase from emergency experts is drop, cover, and hold on. Stay low to the ground. Hide under something stable like a table, and remain there until the shaking stops. Make sure to stay in your shelter for another minute or two, just in case there are aftershocks or loose debris. Use your nose and smell for gas. If you do smell it, don't turn the lights on or do anything that might ignite it. Stay strong and be safe. A tsunami can travel unnoticed in the deep waters at the speed of 500 miles per hour, crossing an ocean in less than a day. When it approaches land, a tsunami will slow to about 20 miles an hour and begin to grow in height. Most of these waves are less than 10 feet high when they hit land, but they can reach more than 100 feet high, about 2 times as tall as the Hollywood sign. When a tsunami comes ashore, areas less than 25 feet above sea level and within a mile of the sea are in the greatest danger. But sometimes, tsunamis can go 10 miles inland. If you're by the coast and feel a strong earthquake, especially one that lasts for more than 20 seconds, that could be a major red flag that a tsunami is on the way. Keep an eye out for sudden changes in the sea level. If the water suddenly recedes way further back than usual, exposing normally submerged areas, that's a sign that a tsunami might be on its way. Plus, if you hear a roaring sound coming from the ocean, like a freight train or a jet engine, that's another ominous sign. And pay attention to any unusual animal behavior. Animals have been known to sense danger before humans did, so if you see birds or marine life acting strangely, it's time to take notice. If you receive an official tsunami warning from authorities, whether through sirens, radio, TV, or mobile alerts, don't ignore it. take immediate action. If you're in a tsunami-prone zone and experience an earthquake, don't even wait for official warnings. As soon as it's safe to move after the shaking stops, head to the nearest elevated area promptly to ensure your safety. Practice evacuation routes before a real disaster. You might have to follow this route at night and in terrible weather. If you know it well, you'll need to do less thinking in an emergency, which can be life-saving. Talk about tsunamis with all your family members. Everyone should know what to do to minimize fear and win some precious time. Don't store your important papers and valuables in low-lying areas. Floodwaters can go really high during a tsunami, so put your documents in waterproof containers on higher ground. After an earthquake, bridges and roads often get damaged or become blocked. Not to get trapped in a car in a potentially hazardous location, walk or run towards safety. Never go down to the shore to watch for a tsunami. If you can see the wave, it means you're too close to outrun it. Most tsunami-prone areas have signs indicating evacuation routes. Look out for white and blue signs marked Tsunami Evacuation Route, or similar instructions to guide you inland and away from danger zones. In urgent situations where evacuation isn't possible, seek refuge on the third floor or higher in a sturdy building. Even better, aim to reach the rooftop of the tallest and most robust structure nearby. It's better than being exposed. A tsunami is not a single wave, but a series of waves with massive amounts of water that can flood for hours. The first wave may not even be the largest. So, remain on high ground, away from the coast until you receive an all clear from the authorities. You're really unlikely to survive a tsunami in a basement below ground level. As it passes over, everything in its wake gets submerged temporarily until the water recedes back to the sea. If you're in a basement during a tsunami, you might get crushed by collapsing buildings or swirling debris. Unless the basement is exceptionally sturdy, waterproof, and equipped with sufficient air supply, it's not a safe option for shelter. If you happen to be out at sea when a tsunami warning is issued for your area, stay put and avoid returning to port immediately. Tsunamis can sneak up on you with rapid water level changes and dangerous currents in harbors and ports, making them unsafe. In large harbors and ports, authorities take charge during tsunami alerts and direct vessel movements for safety. It's important to stay in touch with these authorities and follow any instructions they give regarding moving your vessel. For smaller ports without such organized control, it's a better idea to carefully relocate your boat to deeper waters. If you have a small boat, the best you can do is leave your vessel at the pier and seek higher ground yourself. If a tsunami gets you in the water, find something sturdy like a tree, a door, or a life raft. Grab onto it tightly while you get carried by the waves. Try your best not to swallow any of the water. Tsunamis can pick up chemicals and waste, which won't do you any good. People in life jackets have a higher chance of survival because they will remain on the surface of tsunami waves and can breathe normally. Tsunami waves aren't like ordinary waves, so they aren't suitable for surfing. Tsunamis don't have a face to ride. They're more similar to tides as they rush in and out. They're much larger, faster, and more powerful. So, trying to surf them is not only dangerous but also illegal in many countries. Because tsunamis come from underwater disturbances, like earthquakes, they're even dangerous for submarines. Despite submarines' robust design to withstand underwater pressure, the force of tsunamis can cause damage. Tsunamis also generate strong currents that can mess up a submarine's ability to navigate effectively. In cases of severe tsunamis, submarines may get hull damage, threatening their buoyancy and integrity. Such scenarios can lead to submarines sinking or being carried away by the waves. That's why submarines operating in tsunami-prone areas must be extra careful and equipped to respond swiftly if this sea monster strikes. Scientists still can't predict tsunamis, but they can use their expertise in seismology and historical tsunami data to identify earthquakes likely to trigger tsunamis and issue warnings. They gather crucial data from seismic and water level networks worldwide, which enables them to swiftly assess earthquake characteristics such as magnitude, location, and depth. Utilizing this information, they determine whether an earthquake has the potential to generate a tsunami and decide on issuing tsunami advisories. For regions like the US and Canada, warning center scientists can typically issue preliminary messages within 5 minutes of an earthquake. These messages include alert levels, earthquake details, threat evaluations, anticipated wave arrival times, recommended actions, and potential impacts. On the 26th of December 2004, early in the morning, an enormous earthquake shook up the ocean floor near the Indonesian island of Sumatra. This seismic event unleashed a monstrous series of waves, tsunamis, that spread out across the Indian Ocean, reaching as far as East Africa over the next 7 hours. These waves were towering walls of water, some reaching a height of over 30 feet. When they slammed into the coastlines of countries like Indonesia, Sri Lanka, India, Maldives, and Thailand, the devastation was catastrophic. Over 200,000 people lost their lives in this most devastating tsunami on record. And it wasn't just the immediate impact. Long-term consequences hit hard too. Villages, resorts, farmlands, and fishing areas were destroyed or submerged in salt water along with debris. Japan is one of the most earthquake-prone countries in the world because it's located on top of 4 converging tectonic plates that constantly interact with each other. After a terrible tsunami in 2011, the country started a colossal project dubbed the Great Wall of Japan. With a jaw-dropping price tag of around $13 billion, this wall goes from the north to the south of the country. The goal is to safeguard coastal towns from future tsunamis, buying its people precious time to save themselves. Some locals worry that this towering structure will sever their deep-rooted ties with the sea. They fear losing touch with the ocean's rhythms and cues, which are crucial for spotting upcoming disasters. But for many coastal towns, the wall is a lifeline, giving them hope for rebuilding shattered lives post-disaster.
So, since 2000, the world has been hit with more than 1,700 earthquakes with magnitude greater than 5. Many happened around the Ring of Fire, located around the Pacific Ocean. In North America, the biggest threat is the San Andreas Fault Line, which can create an earthquake of a magnitude higher than any other, earning it the spine-tingling nickname, the Big One. The potential destruction of California is a terrifying prospect that could have unimaginable consequences. But the Big One is just the beginning of what's to come. Bad news! Scientists have predicted an earth-shattering event that will occur in 2030. Like it or not, there's a 70% chance that we'll experience the Big One, and it will be an earthquake with a magnitude of 6.7. The San Andreas Fault Line will cause the Big One, but what is scary is that we can't predict it. On the other hand, a massive earthquake occurs every 100 years. This means there's always time to prepare for a natural disaster. If we traveled back in time, we'd see a few significant earthquakes like the ones that wiped out San Francisco and Fort Tejon. Buildings made a long time ago are not quake-proof. They will collapse. Even if they survive, you should not enter them. But buildings are not the most dangerous part. You should watch out for electrical lines and gas pipes. Your hill house might be lovely, but it is extremely unsafe. During quakes, the hill can turn into a massive landslide that will destroy everything in its path. Say goodbye to road trips because all the roads will be ruined. You should have some spare water and food since you won't be able to go to the supermarket. This disaster won't be cheap. It will cost the US around $200 billion to recover from the quake. At least the earthquake will not trigger tsunamis. But there's something that can cause more damage than the Big One. The notorious Cascadia subduction zones start in California and ends up all the way in Vancouver, Canada. The San Andreas Fault Line is nothing compared to this zone. It can wipe the whole coast off the face of the Earth, an example of hyperbole. Subduction zones are tectonic plates forced to be one under the other and constantly pulling apart. One is called the North American Plate and the other is the Juan de Fuca Plate. Zones like these are not to be messed with, since they are terrifying hotspots for earthquake activity and extremely dangerous because they cause massive underwater quakes. But they are underwater, so what can they do to us? Well, They can cause giant tsunamis, flooding cities, and destroying the coastline. Right now, the most active zone is the Ring of Fire. The Cascadia Zone might be less active, but it is like a sleeping beast that can wake up and destroy everything in its path, causing a groundbreaking earthquake. The last time all this stress was released was in the year 1700. Unlike the San Andreas quake, this one will cause massive tsunamis and much bigger shocks. Let's hope you'll be camping in an open field at that time, because most buildings and bridges will likely be destroyed. Also, be ready for the aftershocks, as they'll be devastating. Nature won't be spared either. Landslides will change animals' habitats. Even our homes will be changed forever. Luckily, there is a light at the end of the tunnel, and scientists are doing everything they can to ensure our safety. New rules are implemented. Every new building must be able to withstand massive shocks. They're developing modern warning systems, and every new infrastructure must follow strict quake-proof guidelines. The Juan de Fuca and the North American plates are locked together, but they won't stay like that forever. When they unlock, get ready for a massive shake. The closer you are to the epicenter, the more damage you'll experience. But even if you are lucky to be far away, you may still feel the ground shaking for some time. Now, if we compare the Cascadia subduction zone and the San Andreas fault, we'll see how much more dangerous the Cascadia zone is. In 1994, there was an enormous 6.7 magnitude earthquake in the Northridge area, close to the San Andreas fault. Sadly, many people didn't make it, and some were injured. Back then, buildings were not strong and earthquake-proof, and many of them were damaged. The Cascadia subduction zone can potentially cause a magnitude 9 earthquake. A magnitude 6 quake has the power of around 44 million pounds of dynamite, but a magnitude 9 has the power of 44 trillion pounds of dynamite. The strongest ever recorded quake was in Chile. Its magnitude measured 9.5, and it destroyed most everything. So let's say you've survived the quake, but the struggle is far from over. Soon after, a massive tsunami will strike, with waves that might reach up to 100 feet in some areas. That's so unlike the San Andreas earthquake, which can't produce any significant waves. So say goodbye to your beautiful garden, since salt water will destroy trees and plants, changing the environment for a period of time. The only positive thing will be you won't need Halloween decorations, because all those dried-out trees will resemble a ghost forest. The combination of waves, quakes, and the sheer size of the area will make this natural disaster much more dangerous than any caused by the San Andreas fault or the so-called Big One. A quake similar to this happened around 300 years ago. Many more have been recorded in the past 3,500 years, proving that they continually occur every 400 to 600 years. So, technically, we have around 100 to 300 years before the next big one hits. We still have no idea how exactly the Cascadia subduction zone works, because we discovered it in 1970. This zone is super scary because it can cause big earthquakes. It was found by accident when researchers studied the Ring of Fire. They wanted to know if this area had caused any trouble in the past years, and the proof was under their noses. In Washington, there is a horror forest where nothing has been growing for years. When researchers tested the soil, they found a tremendous amount of salt. They put 2 and 2 together and concluded that a massive tsunami had been the reason. Experts still didn't know when the forest was destroyed. But Japan kept records of a gigantic earthquake that had a similar effect. It was the one that happened in the year 1700. There is a 1 in 3 chance that the next one will occur in 2050. You must know how to survive the Canadian earthquakes and make it out unscathed, so listen carefully. Those who live in this area have almost no experience with earthquakes like this one. Surviving the quake is relatively easy, but the tsunami coming afterwards is the real danger. After the shake, find the highest ground and go there. Only bring the essentials, like food and water. Yeah, leave your baseball card collection at home. After the first hit, don't try to go down. Seismologists say that most likely there will be a few more waves, and they have proven this. On the 22nd of May, 1960, seismologist Jerry Eston and his 4 friends went to Hawaii to see an expected tsunami that was to happen around midnight. They set up their gear on Wailuku Bridge with an escape route planned. This bridge had been destroyed in the previous tsunami, but the new one was much taller and better. After midnight, the water was 4 feet above the average level. The second wave hit a half hour after midnight, and the water rose another 9 feet by 1 a.m. The water started going down and dropped by 7 feet, but the horror was far from over. Next, they saw a wave that was around 20 feet tall. This shows us that tsunamis are unpredictable, and we should listen to experts to stay safe. You have friends over for dinner. You set your drink on the counter and go help your friend set out some desserts. When you get back, you notice the liquid in your cup. It's sloshing around and the ice cubes look like ships on a rough sea. Now you feel it too. On the ceiling, the chandelier is swinging like mad. Then you hear someone scream, "Earthquake!" The house and everything in it is rocking back and forth. You try to run for cover, but the shaking keeps you stuck in place, fighting to keep your balance. The cabinets look possessed, and glasses and dishes fly out and smash on the floor. The bookshelves topple over, and everything hanging on the walls sways and falls off. You duck under the dining room table, trying not to get hurt on all those broken dishes. Yeah, you've been through earthquakes before, but none like this. Checking your phone? Typical, no signal. You can't believe what's about to happen. The screams get louder, and suddenly the whole house collapses. The biggest earthquake ever recorded happened in Chile in 1960. Disaster came in the afternoon, just when everyone was out enjoying themselves. To cause serious, life-changing damage, you need to have a magnitude of around 7 or so on the Richter scale. This one was 9.5. This part of Chile is smack dab on the so-called Ring of Fire, the most active volcanic and seismic area in the world along the Pacific Rim. The initial shaking lasted around 10 minutes, and after 2 days, many aftershocks were still strong enough to set off a volcano in the south of the country. But that's not where it ended. The earthquake unleashed a series of tidal waves all over the Pacific Ocean, with some reaching over 80 feet high. The waves and earthquake were so strong that they even affected Hawaii, Japan, and the Philippines. It caused around $500 million $1960 worth of damage. Many were left homeless. Much of their infrastructure was smashed too. Buildings as far as the eye could see were toppled, and debris piled everywhere. Scientists estimate that this earthquake was so powerful, it shifted the Earth's axis, making our days 1.26 microseconds shorter. That might not seem like a lot, but think about it. Just one natural disaster was strong enough to make time move. Many of the coastal cities were flattened and floods were widespread. The economy spiraled downward. According to studies, if this earthquake happened today, it caused more than $20 billion in damages. So what would happen if an earthquake twice that size hit without warning? For starters, you'd likely feel the effects even further away. Tidal waves wouldn't just hit the coasts of Japan and the Philippines. They would move even further to China, Korea, Vietnam, and even Australia. And those waves would be significantly higher than 80 feet, perhaps double that. That's like 8 giraffes piled on top of each other, surfing your way. If you lived by the coast, you'd notice the waves. If you saw the water recede way back so you could practically see where all the fish call home, you'd know it was time to run. Chances are that a tsunami's heading your way. Say it really happens. You're caught under the wreckage, not knowing what's going on. You manage to free yourself and escape to the fresh air. And you're not alone, because all the houses in the neighborhood have turned into piles of bricks and rubble. The bridges have also collapsed, leaving people stranded on either side. You look around, dust yourself off, and rush to find help. Fire trucks and ambulances drive between the broken-down cars and rubble. You try to make it to your car, but the aftershocks are still hitting, and you're getting tossed to the sidewalk. With all the cell towers down, you can't call anyone on your phone. Your knees are shaking, but you manage to power through. Once you reach your car, you see it crushed under a boulder, like a giant soda can. You continue on foot and eventually reach downtown. It looks as if some giant got angry and knocked all the buildings down. You push forward and try to see if you can find some help. Without warning, your phone vibrates. You check it and see 1,000 notifications about a 20-magnitude earthquake. You're still shaking, but that's all you. The ground is still for now. Uh-oh. You hear something in the distance, racing towards you. To your right, you see tidal waves as tall as buildings charging at you. Still in shock, not knowing what to do, you now come to your senses and run. You don't even know which way to go. There's a tsunami right behind you, and in front of you are broken down buildings with rocks and concrete still falling everywhere. Wait, there's a building that's somehow still standing. You need to get on top of that thing. You reach the elevator, but it's jammed. Not surprising. You bolt up the stairs as fast as you can, tripping on broken glass and plaster, but always managing to get back up. You look out a window and see the water. It's so close. You're nearly at the top. A few more flights and whoosh. The water forces its way into the building and drags you down at least 2 floors. You can barely see anything. Still, you know you must swim up. But the water keeps forcing you downwards. After about 30 seconds, you manage to swim your way out and continue climbing to the top. You scramble to the top floor and collapse on the roof. You're safe for now. The tidal wave is still going strong, plowing its way through the ravaged city center. Your phone is now waterlogged and useless. You have a perfect 360-degree view of your town covered in water and debris. The ground starts to shake again. Maybe you'll just sit around until this is all over, waiting for the rescue helicopter. But then, a loud explosion that almost breaks your eardrums shakes the ground even more. Off in the distance, smoke is rising, and soon it covers the entire sky. Darkness hides the morning sun. That's when you can see lava shooting up into the air and landing nearby. The lava forms into a river, flowing its way into town block by block. With this much seismic movement and the high intensity of the earthquake, the world's tectonic plates have shifted so that magma is pushing its way to the surface. From the earth, steam begins to vent. Then the heat hits you. You see the magma cover the ground like a blanket, eating up every car in its way. What's worse is that the magma is melting the foundations of the buildings that managed to withstand the earthquake and the tsunami. The buildings in the distance are now sinking and collapsing into the raging lava pool that's replaced your town. One by one, every building descends. That means, uh-oh, the building where you're standing is also swaying. It's about to fail. That's when you see the light. You look up and see a helicopter above in the distance. You wave your arms, run around, jump, anything to get noticed. And it works. The chopper makes a few circles and finally drops you a rope ladder. As you're lifted in the chopper, you take a good look at the world below you as it wriggles around like noodles in a strainer. You land a few miles out and are immediately treated by a doctor in an emergency triage center. You were one of the lucky ones. A year later, the tsunami water has receded. The lava that flowed inland has cooled, but all that magma permanently changed the ground below it, and the whole town is gone. The disaster has thrown the entire country into a financial nightmare that'll last decades. It takes months to survey the town, making sure there's no dangerous electrical wires or busted gas pipes anywhere. They're rebuilding your town farther inland from where the old one was. In other towns, they rebuild directly over the ruins. In others, they just decide to move everyone to a nearby city.
How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, Less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic. You rub your eyes, trying to make sense of everything. Perfect circular holes in the bottom of the ocean floor off the coast of Big Sur in California. You have no idea how this happened, even though you're a marine biologist who's been practicing it for years. You go through some of the old records and find out that these holes have been around since the 90s. In 1999, a ship-mounted sonar conducted a survey and found 5,200 of these pockmarks, or large holes over 500 square miles, on the ocean floor. They look like moon craters underwater. You contact your team and get the robot ready to go down and explore the scene and bring back a few samples. You and the team drive to the coast and hop on the boat. You're sitting inside controlling the robot with a joystick. Your teammate sets the robot in the water and drives it down. Everything seems normal near the surface, but as the robot goes lower, the pockmarks start appearing. A bunch of boats swift past you, making you lose your balance and focus. The robot turns on the flashlight so you can see better. But as it goes lower, the resolution is less crisp. It almost reaches the bottom, and the holes are smooth and nearly perfect circular shapes. Some of these holes that were visible in the sonar reading measure more than 30 feet across and 15 feet deep. You show the rest of your teammates the images, and they're shocked. The robot continues swimming, but there appear to be more holes all around. Many of them are too small for the scanner to capture from above. These microdepressions are steep and have sort of tails going in a certain direction. It's possible that the currents underwater played a role in their shape. Everywhere the robot swims, there are new holes all around. After a couple of hours, the robot goes back to the boat with some samples. You take them back to the lab and study them. The robot clearly captures images of human trash. but the samples don't indicate anything alarming for now. Despite the fact that 1/3 of the pockets are filled with trash, there's still no explanation of how they were formed. It's late at night and the rest of your team heads back home. You're passing out in the lab, still trying to find some answers. You wake up the next day and while cooking breakfast, you get this idea that maybe these holes are gases venting out, which could be harmful to marine life. You quickly get the robot and sail out to the ocean once more. This time, you didn't even think about calling your teammates. You place the robot in the water and get behind the screen to control it. The robot descends to the bottom of the ocean and does a survey. So far, the holes still seem to be covered with trash. But some of the holes have marine life dwelling inside, like fish and seaweed. After much scanning, it doesn't look like they're producing any bubbles, which means there aren't any gases venting out, but you're determined to find them. After a while, you reach one of those large pockmarks, and the robot starts scanning around. You find some bubbles coming from a source, but the robot can't reach it. It swims around trying to find a spot, but nothing. You bring the robot back to the lab and work on it. You attach some mechanical arms on it that can lift things and move them. You bring the robot back down to the same spot, but the bubbles aren't as frequent as before. You use the arms to move some of the trash and find out that the bubbles are being produced by a group of crabs chilling next to a pile of plastic. Bingo! The bad news is, you still don't have a clue why the microdepressions and pockmarks exist. As you try to control the robot to go back to the surface, an octopus wraps its tentacles around it, pulling the robot down. You struggle with the controls and push it to maximum power, but the suctions of the octopus are too strong to break off. It's a game of tug-of-war with the octopus and your robot. It takes the robot under a pile of trash, thinking it's lunch. But you use the arms to maneuver the robot out and swim back to the surface. You go back to the lab even more confused. The robot has collected more samples for you to study. Your eye is glued to your microscope, trying to figure out what's going on, but nothing. You decide to do a carbon dating test to determine how old these holes are. After a while, you check out the results and are even more stunned than before. They show that the holes are around 400,000 years old, so it's likely that human trash wasn't the cause for all this. You pull many all-nighters trying to figure out the truth. You gather your team once more and hold a small press conference about this. You claim that this may be something we should be extremely worried about, but you still can't tell them more than what you know. With all the brain work put together, you find out that the large pockmarks haven't changed or been active for more than 50,000 years. The newer holes were most likely created by human trash settling in the bottom of the ocean floor. The marine life gathered some of this trash like plastics and discarded fishing gear and created homes for themselves. This is why around 4,500 of the holes are newer and have trash in them. But it still doesn't answer why the holes appeared in the first place. You're back to square one. The only way to see what's really going on is to clear up the trash from underwater and study them. The story makes headlines in the local community and catches the attention of a cleanup crew. You organize a trip to the ocean and begin the extraction of all the trash. Many cleanup boats arrive and everyone drops down a net to collect the trash. You send down the robot once more to make sure the nets are hitting the right spot. As most of the trash is being collected, many marine life animals scramble and try to find a way to escape. Everyone makes sure not to hurt them. After a couple of weeks, all the holes are cleared up from the trash. You do another sonar scan from the surface and can see the holes clearer than before. But you still don't have an answer for this. You do some more research trying to see if any other holes appeared around the world. On the other side of the country is a mysterious blue hole off of Florida's Gulf Coast. You catch the nearest flight to Florida and make an appointment with the scientists in charge of the expedition. Blue holes are underwater sinkholes that open below the seabed. Just like on the surface, the underwater world also has sinkholes. This one is called the Green Banana and is 150 feet below. And the hole is 435 feet deep. You dive with some special gear with the rest of the team to a barren ocean floor, and the hole is right there in front of you, looking like an oasis in the desert. You and the rest of the scientists are surprised by the diverse marine life dwelling within. Some sea turtles swim past you, and even sharks. These ones don't harm humans. Halfway through, you reach a narrow path, which makes it difficult for humans to pass through. But everyone is careful. There are corals, sponges, mollusks around the corner. You collect some samples and go back to the lab. Blue holes in general are richer in nutrients than barren lands and host plenty of unique marine life. They're quite common and don't pose any sort of threat to anyone. After making the connections, you don't think the holes off the coast of California have anything to do with blue holes. The mystery goes on.
So get this. Taylor Swift takes a flight from Los Angeles to Tokyo that leaves at 10 a.m. on February 20th. She's on the plane for 12 hours, but she lands only at 2 p.m. the next day in Tokyo. That's a 28-hour difference. So, how did this time warp happen? Well, it's all because of this wonky line. This is the International Date Line. You know, that imaginary line that slices the globe in half and decides who gets to celebrate the new year first? It's the Line Islands, by the way. But crossing this line doesn't just make you feel like you've stepped into a transporter. It actually changes your day. Cross from east to west and boom, it's 24 hours later. If you travel in the opposite direction, crossing the line from the western side to the eastern side, you go back an entire calendar day. Now, you'd think that the International Date Line would be a nice, neat, straight line in the ocean where the time zones switch. But in reality, it's as if someone took a ruler and said, let's make this complicated. The line zigzags all over the place, wrapping around islands and causing all sorts of head-scratching confusion. For instance, Big Diomede Island and Little Diomede Island are only 2.5 miles apart, but have a 21-hour time difference. And things can get a little more complicated depending on which time zone a country follows. For example, if you travel 659 miles across the date line from Baker Island to Tokelau, you must add 25 hours. In other words, that's 1 day and 1 hour. And if that doesn't sound weird enough for you, wait, it gets crazier. When it's 6 o'clock in the morning on Thursday in New York, it's still Wednesday night in American Samoa. Meanwhile, over in Kiribati, it's already Friday. Yep, we're talking about 3 different calendar days happening at the same time because of this one imaginary crazy line. This phenomenon occurs every day between 10 o'clock and 10:59 in the morning. So, why does the International Date Line look so ridiculous in the first place? Well, great question. Although these zigzags may seem completely arbitrary, they actually have a logical basis. It's pretty much a made-up concept based on the Earth's rotation. The Earth is always spinning, thank goodness, and it takes about 24 hours, or a day, to complete one full rotation. To keep things in sync, people took the Earth and divided it into 24 time zones, each 15 degrees apart. But what is the starting point for a day on Earth? Well, basically, people needed to figure out which of these 24 zones or lines would be the starting line, or the chronocenter. They needed a reference point, a line where they could begin adding or subtracting time as you move east or west. That line is what we now call the prime meridian. But here's the catch. Deciding where to put this starting line, the prime meridian, is totally arbitrary. The idea of establishing a line where days begin and end goes all the way back to at least the 1300s. Back then, map makers were doing their own thing, picking their own east-west dividing lines called meridians, which, by the way, is just a fancy Latin word for midday. Without a universal standard for when a day officially started or ended, sailors on long voyages just had to wing it, figuring out how to handle the time they were gaining or losing along the way. So, in 1884, people decided to organize this whole mess. 25 nations gathered at the prestigious International Meridian Conference in the United States with one big goal: to decide on a line that would serve as the official prime meridian. Finally, like it or not, they were determined to create the International Date Line that the whole world would accept and would follow from that point forward. The prime meridian was established in Greenwich, England, and the international dateline was placed on the opposite side, running through the 180th meridian. Well, sounds simple, right? But that's when the nightmare really began. The chosen international dateline didn't just wander through uninhabited areas. Oh no! It split some countries in half and created all sorts of chaos. I mean, if you divide the world with a completely straight vertical line, you end up with situations where half of a country is one day ahead and the other half is one day behind. Take Kiribati, for example. The country is primarily centered in the Gilbert Islands, which sits just west of the international dateline. However, in 1979, their territory got a little bigger with the Phoenix and Line Islands, which are way east of the dateline. Suddenly, Kiribati was straddling the international dateline. This created a bit of a headache for businesses. Folks on either side could only communicate by radio or phone for 4 weekdays a week. Now, to fix this quirky situation, Kiribati decided to skip Saturday, December 31st, 1994, right off the calendar. So Friday, December 30th, turned into Sunday, January 1st, 1995. And just like that, New Year's Day came a day early. Woohoo! After that, the dateline moved eastward to go around the entire country. So the same thing that happened to Kiribati happened to other countries as well. For example, when they got to the Aleutian Islands in Alaska, the line made another detour to include them. And when they got south of the equator, well, guess what? Another eastward bend to cover even more islands. And that's pretty much why the straight line started to get a bit ziggy-zaggy. This wonky line is designed to avoid land as much as possible, so there's less hassle when it comes to changing days. So, no, you can't stand between the international dateline, like having one foot in one day and the other in the next. But you can cross it by boat. In fact, some fancy trans-Pacific cruises even offer a time travel package for adventurous travelers who want to cross the line and jump into the future. Now, in the end, the international dateline looks this ridiculous because it was constructed based on a series of arbitrary decisions, historical quirks, and a whole lot of confusion. But it's not just because people organized it in the 19th century that there is no confusion regarding time zones today. Another thing that the prime meridian establishes is Coordinated Universal Time, the famous UTC. Now, UTC never changes for daylight savings time or anything else. However, in 1908, Canada decided to spice things up by creating Daylight Saving Time, or DST. Their idea was to set the clocks 1 hour ahead of Standard Time to make better use of sunlight in the spring and summer and fall evenings. The idea was so brilliant that most countries jumped on board, but not everyone. Just look at Nepal. They have never ever used the Daylight Savings Time, which means their clocks do not change throughout the entire year. As you probably know, countries with large territories often have more than one time zone. Just like the United States, which has 11 time zones. Australia has 9, while India is a special case. Look, India is a big country with an area that stretches around 1,800 miles from west to east. So it should have 3 time zones in total, but they only have one. This means that the sun rises almost 90 minutes earlier in Dong in the Far East than in Gujarmoti in the West. And why do they have only one time zone? Well, basically, because they can. Just remember that the international dateline and time zones are invisible, artificial, and now you know, totally arbitrary. So if a country wants to stick with just one time zone to simplify processes and business operations within its border, then hey, why not? Hey, do you believe in folklore telltale signs that can help predict the weather? Actually, many of them even have a scientific backup. So let's dive in. You've probably heard this one at least once. Red sky at night, sailor's delight. Red sky in the morning, sailor's warning. Oh, you haven't? Then you might have heard a variation with the word shepherd instead of sailor. This weather lore was even commemorated by William Shakespeare, I call him Bill, back in 1593. He wrote a poem, Venus and Adonis, and there is a description of the red sky lore. Turns out Bill was right, and this one can be explained. The red sky appears when dust and small particles are trapped in the atmosphere by high pressure. When sunlight passes through the Earth's atmosphere, it splits into different colors of the spectrum and creates colorful skies. If there's a high-pressure system, it can trap dust and vapor in the atmosphere, causing blue light to scatter and leaving only red. So it can indicate that the weather will be clear and calm the next day, whereas a red sky in the morning can indicate a storm is on the way. How about another one with sailors? Rainbow in the morning gives you fair warning. Rainbow at night is a sailor's delight. Now this suggests that if you see a rainbow in the morning, it means that rain is on the way. However, if you see a rainbow at night, it means that the weather will be calm and clear the following day. And the pot of gold at the end of the rainbow is still a myth. Next one. They say no weather is ill if the wind be still. This one's pretty logical too. Calm weather conditions show us that the pressure is high in this area. Highs are regions of descending air, and they prevent bad weather phenomena, such as clouds and precipitation, from forming. But there's more to that. Actually, calm conditions may be a true sign that bad weather's on the way. We often call it the calm before the storm. Have you ever seen this halo around the sun or moon? Well, it's another telltale weather sign. Next time you spot such a halo, make sure to grab an umbrella before you leave the house. This phenomenon occurs because of refraction. The sun and moon provide light, although in different ways, and this light gets refracted by ice crystals at high altitudes. When you see a halo, it means that the moisture up there is going down. Also, these halos may evolve into another beautiful phenomenon, milk sky. The milk sky is still clear, but the typical blue shade is sort of washed away and appears a bit faded or milky. Today, we can just check the weather forecast on our iPhones. But centuries ago, people needed to have some alternatives to be able to predict the weather. The very first weather forecasts appeared around 650 BCE. Back then, the Babylonians would predict weather using cloud patterns. Ooh, that's a fluffy one. Uh-oh, there's a dark one. We should go inside. People had to wait for quite a lot of centuries for mass weather forecasting. The first prototype of what we have today appeared in 1835, and it was thanks to the invention of the electric telegraph. By the way, back in the olden days, animals contributed a lot to weather forecasting. Some traditions are preserved up to today. For instance, Groundhog Day. Long story short, if the groundhog gets out of its den on the 2nd of February in Punxsutawney, Pennsylvania, and sees its shadow, it will go back into the den, and the winter will last for 6 more weeks. On the contrary, if the groundhog does not see its shadow and doesn't get scared, spring will arrive soon this year. There's no actual scientific backup to this tradition, but surprisingly, in most cases, the groundhog predictions come true. Well, in the US, people get predictions from groundhogs. In Croatia and Serbia, people use bears to see if spring's on the way. On the 15th of February, they watch a bear awaken from winter dormancy. It's all about the shadow again. If the bear gets confused when he sees his shadow, it will go back to its den and sleep for 40 more days, thus prolonging the winter. But if it's cloudy on this day, it's a true sign that spring is coming. As to the poor schmuck who has chosen to wake the bear up, I think I'd pass on that honor. Unlike groundhogs and bears, seagulls can help predict bad weather all year round. They say, "Seagull, seagull, sit on the sand. It's never good weather when you're on the land." These birdies tend to sleep on the water, so if they sense turbulent wind, they prefer not to struggle with it but avoid it. Therefore, they just land on the beach and wait. Smart! Rain before 7, clear by 11. Pretty common, but only partly true. The occurrence of late night and early morning rains may be due to the passing of a weather front. Still, it's not 100% correct to assume that morning rain is a sign that the afternoon will be dry. In some cases, a rainstorm that develops in the late afternoon may last up until the night, causing early morning rain. Now, cows could make good weather forecast reporters too. A cow with its tail to the west makes the weather best. A cow with its tail to the east makes the weather least. Thing is, they don't really enjoy it when the wind is blowing right in their faces, so they prefer to stand with their backs to the wind. Winds blowing from the west usually bring good weather, and those blowing from the east, on the contrary, are likely to provide unsettled weather. Voila! I told you, cows are cool. So, should you ever be in a pasture with cows? You will know what weather it will be in the next few hours, even if there's no coverage and you can't use your phone. Now, in case there are no cows, bears, or any other animals that are sensitive to the weather, you can use onions. Yep, you heard that right. Even onions can predict the weather, and these guys actually predict long-term conditions. Here's a nice rhyme. Onion skins very thin, mild weather coming in. Onion skins thick and tough, coming winter cold and rough. Well, seems there's no prediction connected to French fried onion rings though. If you want to hear a scientific explanation for this, sorry, there won't be any. In fact, scientists say such rhymes have stood the test of time for one reason only, and it's our human selective memory. We tend to remember things we've predicted correctly, and if not, we just forget them. Oaks and maples can be helpful though, due to their ability to curl leaves when the humidity is very high and the wind's blowing strongly. So, when leaves turn their back, 'tis a sign it's going to rain, turns out to be quite a true saying. There's even a rhyme for it. When the leaves show their undersides, be very sure that rain betides. I know, betides, it's kind of a forced rhyme, but it is a word, it means happens. Okay, time to move on, let's not beat a dead horse, which, by the way, is not a weather predictor. So hey, did you know that you can even use your friends to predict the weather? Our human body is way more multifunctional than you could have imagined. Here's another short rhyme to prove we humans have superpowers. For instance, our body can predict rain. I know ladies by the score whose hair foretells the storm. Long before it begins to pour, their curls take a drooping form. See? I bet you've noticed it many times and maybe even correlated that our hair may act weirdly when the humidity rises. It may expand in length due to humid air, and naturally curly hair may droop. Naturally straight hair, vice versa, may even curl up a bit. If you have blonde hair, you're even more potent at rain forecasting, as it's more sensitive to humidity. On to more precise predictions. Yeah, it's cool to predict the weather, but what about predicting temperature? You can tell the temperature by counting a cricket's chirps. These guys are quite accurate thermometers. When it's warm, they chirp faster. When it's cold, their chirps get slower. Now, here's what you need to do to get the temperature. Count their chirps for 14 seconds, and then add 40 to the resulting number of chirps. Now comes the disclaimer. Crickets only work in Fahrenheit. For Celsius, you'll need to do some extra calculations. While not all weather lores are accurate all the time, they can be a fun way to predict the weather and connect with nature. Meanwhile, my hair is turning frizzy, so I'll grab an umbrella. Now, have you ever wondered about the longest time it rained nonstop? Even an hour of rain could be a big deal if you're hanging out in a dry spot like the Atacama Desert in South America. It can set a record for that place. But in super rainy spots like the Amazon rainforest, having 40 days of rain in a row might not even turn heads. Interestingly, we only have rainfall records where people live and keep track. Many towns and cities skip the whole rain data collection thing. Plus, there are so many places on Earth where nobody lives, like rainforests or the open ocean. So our rainfall knowledge is a bit patchy. Now, if we were to talk about records, Hawaii has a couple. People there have some seriously long rainy days, especially on islands where winds come from the mountains. From 1939 to 40, they recorded 331 days in a row with measurable rainfall. If you're a person who likes to watch the rain at home with a cup of tea, this might sound ideal to you. But we need to see the sun at least occasionally. Getting some sun is good for your body and soul. Obviously, you get vitamin D. Just 5 to 15 minutes of sunlight a few times a week can make a real difference. And have you ever heard the phrase sunny disposition? Researchers found that people feel down when there's not much sun around. Sunny days make us happier. Sunshine boosts your serotonin, which fights off bad moods. That sunny serotonin isn't just for your mood, it also helps you sleep. And it's also a heart assistant. When the sun hits your skin, your body releases something called nitric oxide, which chills out your blood pressure. Healthy blood pressure means a healthier heart. Now, go tell that to the people who had to go through 881 consecutive days of rain. Yeah, the record was set almost 3 full years of rain. This happened from 1913 to 1916 in Hanaumomaki, Hawaii. It rained like there was no tomorrow because the region is a tropical rainforest. How do clouds make rain? Well, rain happens when damp air goes up into the sky and gets a bit chilly. As this air cools down, tiny water vapor molecules huddle up, forming super small droplets that look like a fluffy cloud team. Now, inside these clouds, things get playful. The air moving around can sometimes make these droplets bump into one another and get bigger. Then they can turn into ice crystals high up in the clouds where it's chilly. These little ice buddies get heavy enough to take a tumble down, melting in the rain on the way to the ground. Now, there isn't just one type of rain. Raindrops can come from all kinds of storms. Thunderstorms show up, make a splash, and then they're out. They can dump a ton of rain in no time. Other storms, like winter storms, are more laid back. They stick around for days and dish out gentle rain or even snow if it's cold enough. Usually, the weather switches between moods. It's nature's way of balancing things out. After stormy weather, the sun comes out, the air dries up, and we get to enjoy some clear skies. But things can get interesting if you're in a place with mountains near the ocean. When moist air hits the mountains, it's forced to climb over them, creating rainfall lasting sometimes for weeks. What if I told you there was a time on Earth when rain fell continuously for 2 million years and completely reshaped the planet's destiny? At the end of the Permian era, around 234 million years ago, I wasn't around then, but I read about it, the Triassic period began, marked by the onset of an extended period of rainfall. This phenomenon is now called the Carnian pluvial event. Well, that's what they decided to call it. Recent studies, supported by evidence, suggest that it didn't reshape the planet in that sense, and that it was triggered by coal combustion. The rain wasn't continuous either. So we just debunked a myth here. Woohoo! Next, we have columnar jointing. This is the fancy term for groove patterns that form in lava flows, sills, dikes, and other rocky stuff. These lava creations come in all shapes and sizes. Most are seen as straight, parallel columns. Some have curves and varying widths. They can be as high as 1,181 inches. I'll save you the math. It's roughly 98 feet. The columns are formed by pressure and the cooling process. As lava becomes cooler, it shrinks and forms cracks. Once a crack starts, the lava moves around. These cracks expand to the surface of the flow. Water sneaks into the cooling lava, making it chill down fast starting from the surface, leaving its mark in those patterns. Devil's Postpile in California is a must-visit place if you want to see columnar jointing. But hey, they're found all around the world. Let's raise our heads to the sky to see something magical. Fire rainbows, also known as circumhorizontal arcs, look like flames dancing above the clouds. To see these eye-catching arcs, you need a special cloud type called cirrus clouds and the sun at least 58 degrees high in the sky. It's a VIP collaboration between sunlight and clouds. Let's break it down further. Take London, for instance. It's around 51 degrees north. Now, sorry Londoners, no fire rainbows for you. Now we move to deep waters to see underwater crop circles. These are giant circular patterns found in 1995 near the shores of southern Japan. Locals were baffled. They dubbed them mystery circles, as if the ocean had a secret talent for sand art. The mystery was solved in 2011. The unlikely artist turned out to be a tiny pufferfish, just 5 inches long. The researchers found out that males were on a mission, spending a solid 7 to 9 days building their circles by swimming in and out and using their fins to carve valleys into the sandy floor. They decorate the peaks of their creations with bits of shells and corals, turning their sandy canvases into masterpieces. Okay, they don't do it for the sake of art. The curious circles have a purpose. The sandy center of the circle serves as a nest. Male swimming moves mix things up, getting sand particles just where they need to be. When a lady pufferfish swims by, the male twirls and dances, swirling sand around. If she is impressed and thinks he is the one, she lays her eggs in the sandy heart of the circle. There you go, another happy ending. Now let's look at frost flowers. You might have seen thin sheets of ice that look like delicate petals and sometimes pop up from the stems of plants. The ice is about as thick as a credit card. It forms when the weather is cold outside. The soil is damp but not frozen, as well as plant stems. Not all plants produce these frost flowers, and the conditions must be just right. Here's how it happens. The water inside a plant stem gets pulled up from the ground. When it freezes, it expands and cracks the stem vertically. As it hits the chilly air, it turns into ice. As more water gets pulled up through the crack, it keeps pushing out super thin layers of ice. Whether a frost flower looks like a narrow ribbon or a wider one depends on the length of the crack. And the way it curls and shapes itself into these petals is random, or the reason might lie in the difference in friction along the sides of the crack. These frost flowers are unique and delicate, and they don't last long. They melt or just disappear quickly. To spot them, keep an eye out for tall grass, especially in places that don't get mowed much. Pay attention to purple ironweed, blackberries, and wingstem.